Hello and welcome to Sleep Science Space, a quiet little corner where big questions slow down enough to be whispered beside your pillow, where science moves at the rhythm of a calm, steady breath. Tonight, we're going to wander gently into one of the most overwhelming questions the human mind can ask: how big is the universe compared to the galaxy we live in? It sounds like a question about numbers, about distances and measurements. But underneath the statistics is something softer: the feeling of standing inside one enormous structure while looking out at something even more enormous beyond it. We are already living inside something vast, and yet we're surrounded by something larger still. This evening, I'd like to walk with you slowly and unhurriedly through that difference. Before we set off, you might take a moment to notice where you are listening from. Maybe you're in a bright city where only a few stars manage to peek through the glow of street lamps. Maybe you're somewhere rural where the Milky Way spills across the sky like a pale, luminous river. Perhaps it's late at night, your body already tucked under a blanket, eyes heavy. Or maybe it's a quiet afternoon and you're simply offering your mind a gentle place to rest for a while. Wherever you happen to be, and whatever the time on your clock, you and I are sharing this small slice of space time together, and that in its own way is already a tiny miracle in a universe this big. If this kind of slow, soothing exploration helps you unwind, focus, or drift towards sleep, you're welcome to tap like or subscribe so that others who might need a soft, steady voice to float along with can find their way here too. For now, though, there's nothing you need to do and nowhere you need to go. Just let your body settle a little more deeply into your chair or your bed. Feel the pillow supporting your head, the weight of your limbs, the rise and fall of your breathing. Let one slow breath in and one slow breath out be the way we step together into the cosmos. It can help to imagine yourself outside beneath a clear night sky. The air is cool and still. Above you, the darkness opens like a dome. Scattered across it are points of light. Maybe you see only a few dozen softened by the glow of the city. Maybe you see thousands, sharp and bright. Each one of those points is a distant sun, many with their own families of planets, silently circling all of them, belonging to something larger than themselves. When you lift your gaze to those stars, you're not just looking at random specks of light thrown across space. You're seeing a tiny part of a grand structure, a spiral galaxy we call the Milky Way, whose gravity gathers these suns into a vast, swirling pattern. This galaxy stretches so far across space that even a beam of light, the fastest thing we know, would need tens of thousands of years to travel from one side to the other. And yet, for all that immensity, the Milky Way is just one galaxy among billions, perhaps trillions, that make up the universe as a whole. It is like a single glowing leaf in a forest of unimaginable size. It's easy to say those numbers out loud, to talk about light years and billions and trillions, but the feelings they stir are often bigger than any figure we can quote. Tonight, we'll try to take that comparison gently, step by step, the way you might walk down a dim hallway with a small nightlight in your hand. The words and numbers we use will still be only signposts pointing vaguely towards something our minds can only just begin to picture. But as we move through them slowly, with curiosity and without hurry, they can become something soothing, a reminder that being small in a universe this vast is not a problem to solve, but a quiet truth to rest inside. When you stand beneath the night sky, it's easy to slip into the feeling of being tiny, like the universe is stretching outward in every direction, endless and overwhelming, while you exist as a faint dot within a larger dot disappearing into the background. But there's another perspective that can feel softer, truer, and far more comforting. You are not say out at the universe looking in. You are inside it. You are part of it. The atoms that make up your bones and your breath were forged in ancient stars long before Earth existed. The space above you is not separate from the space you occupy. It is one continuous fabric, and your body is woven from the same materials as the galaxies we're about to explore. So instead of shrinking, you might find yourself expanding, feeling included rather than diminished. Let that awareness settle gently. It is extraordinary that we can even ask questions about the scale of the cosmos. For most of human history, the universe was simply the sky overhead, a luminous dome scattered with stars. People saw a glowing band stretching across that dome, but they had no idea it was an entire galaxy viewed from within. The idea that this band was a disk of hundreds of billions of stars and that this disk was just one out of countless others is a remarkably recent realization. Only about 100 years ago, astronomers were still debating whether other galaxies existed at all or whether the Milky Way was the entire cosmos. Today, we know it is merely one island of light in a vast cosmic ocean. In just a single century, a blink on the timeline of humanity, our understanding of size has expanded into something almost beyond language. That expansion is what we're going to walk through together. Think for a moment about distances in your ordinary life. A few steps to the kitchen, a walk down your street, a drive across town, a flight over an ocean. These distances feel real and comprehensible because you can sense what they demand minutes, hours, maybe a day. But when we begin comparing galaxies or trying to measure the universe itself, ordinary units fall apart. Words like miles or kilometers become too small to be meaningful. So astronomers use light years, the distance light travels in 1 year, nearly 10 trillion kilometers. Light is the fastest thing we know, and even its speed strains to keep up with cosmic scale. The Milky Way spans about 100,000 light years. Already that number stretches the imagination. Yet compared to the observable universe, which extends more than 90 billion light years across our galaxy, is a tiny glowing curve on an almost unfathomable map. This is where imagination becomes a companion, not a limitation. Tonight we'll move slowly through these comparisons, giving each number room to breathe so the scale becomes less abstract and more like a quiet landscape in your mind. You'll gently place yourself inside the Milky Way. Feel its width, then look outward toward the clusters of galaxies surrounding us, and finally open your awareness to the observable universe. You won't walk away with a perfect visual that's impossible, but you will carry a soft, intuitive sense of how our home fits into the greater whole. That's all you need. Even a faint impression of that scale is enough to leave your mind both humbled and soothed. Take another slow breath. Return for a moment to the feeling of standing under the stars. Notice their subtle twinkle, how some glow softly while others shine sharply. Everything you can see with your eyes, every pinprick of light in the whole night sky, is only a tiny fraction of what truly surrounds us. In most places on Earth, the naked eye can detect just a few thousand stars, a gentle whisper compared to the full symphony of the galaxy beyond. But the Milky Way you see overhead is only the faintest whisper of what it truly contains. Our galaxy holds not just thousands of stars, but hundreds of billions of them, most too distant or too dim for the human eye to detect. If you could make the night sky as you know it and multiply it by 100 million, you would be approaching the true population of suns drifting around us. And even then, this enormous gathering of stars, gas dust, and unseen matter is only one galaxy in a cosmic sea overflowing with others. It's the difference between a single grain of sand and an entire shoreline, between one page and an entire library. The numbers grow so large, they almost become playful, as though the universe itself is smiling at our attempts to measure it. Yet here we are, lying comfortably in our homes, letting our awareness float across those scales without needing to grasp them with precision, only to feel their quiet magnitude. It's worth asking why thinking about something so overwhelmingly big often makes us calmer instead of anxious. You might expect the opposite. But when we place our lives alongside something as immense as the cosmos, the mind often softens. Problems shrink, urgencies loosen. The pressure of a single moment becomes lighter against the backdrop of billions of stars and trillions of galaxies. It doesn't mean your concerns are unimportant. They matter deeply. But they settle into a wider frame, and that larger frame creates balance. You are not the center of everything, but you belong inside everything. There is room for you physically, emotionally, cosmically. Now let your awareness drift back down to the earth beneath your feet. This little blue world is where all our journeys begin. From here, we lift off gently in imagination first into the familiar neighborhood of space, and then outward into the grander structures beyond. Earth itself is around 12,700 kilometers wide, a size you can almost feel. A long flight can cross a continent. A spacecraft can circle the globe in less than a day. But once you expand to the solar system, where Neptune loops around the Sun nearly 5 billion kilometers away, Earth suddenly feels small. And when you place that solar system inside the Milky Way, a structure stretching more than 100,000 light years across it becomes a speck too tiny to mark. Then compare the Milky Way to the observable universe, a region more than 90 billion light years wide, and even our entire galaxy fades into a barely noticeable point. This stack of scales is what makes the question so mesmerizing. Every level is a universe of its own, and yet every level becomes minuscule when viewed from the next step up. And this breathtaking cascade is only where the story begins. For now, we're still together beneath the quiet glow of the stars, gently asking how it all fits. The night is soft, the air is still, and the thought remains simple and soothing. The galaxy is unimaginably large, and the universe is larger still. When we talk about the place we belong to, the mind usually stops at Earth, our landscapes, our weather, our moon, our sun. Sometimes we stretch a bit farther, imagining the planets drifting nearby. Anything beyond that often feels distant, almost like a different category of existence. But in truth, the larger home we live inside isn't Earth at all. Our true cosmic dwelling is the Milky Way itself. The galaxy is not something hovering far away in the sky. It is the structure we are fully immersed in every moment. Every star you've ever seen, every planet you've ever heard of, every sunrise, every moonlit night, they all unfold inside this single, immense galactic home. Understanding the Milky Way, even in the softest, simplest way, is like stepping back and seeing the shape of the entire house instead of focusing on just one familiar room. Tonight, we're going to walk gently through that wider home, noticing its proportions, its quiet architecture, and the place we occupy within it. Imagine drifting far enough away from Earth that the atmosphere fades, the planets fall behind, and the sky opens into pure darkness. From that distance, the Milky Way finally reveals its form. Here on Earth, we only ever see it edge on, a glowing band stretched across the night on clear evenings. But from the outside, the galaxy becomes a spiral, an elegant disk with long arms sweeping outward like slow cosmic brushstrokes. Each arm is filled with stars, clusters nebulae, and drifting rivers of dust. At the center sits a densely packed sphere of ancient suns circling a supermassive black hole called Sagittarius A silent gravitational anchor holding the entire system together. The Milky Way glows in wavelengths our eyes cannot detect: radio, infrared, ultraviolet, an enormous tapestry of energy threading itself through space. To describe the shape in words is simple. To truly imagine standing outside and looking back is far more difficult. But even without seeing it directly, we can place ourselves gently into the map of it. The disk of the galaxy spans about 100,000 light years from side to side, and its thickness is only about 1,000 light years. Inside this thin, radiant disk, billions of stars orbit the center in a slow, swirling rotation. Our solar system is far from the crowded core, perched quietly on a minor spiral branch called the Orion Arm, about 27,000 light years from the center. That distance alone stretches the mind. Light, the fastest thing we know, takes 27 millennia to cross the space between the core and the place we call home. When astronomers observe the center of the galaxy, they aren't seeing it as it is now. They are seeing it as it was long before the first human stories were told. The Milky Way contains its own deep timeline, carried simply by the slow travel of light. Pause for a moment and imagine what it means to live inside such a disk. The night sky above you is not random. It is shaped entirely by your position in this great structure. When you look toward the dense milky band stretching overhead, you're looking into the plane of the disk, where stars are packed more closely together. When you look away from it, the sky thins because you're gazing out of the disk and into the more spacious halo that surrounds it. You are always inside the galaxy, just seeing different densities depending on where you turn. It's similar to standing in a forest. Look down the line of trees, and they seem countless packed together in long repeating columns. Look straight upward, and the branches open, the sky shows through, and everything feels airier. It's the same forest, only viewed from different angles. Our galaxy behaves in the same way, except the trees are stars, and the forest spans tens of thousands of light years. Within this home, there are landmarks as distinct as ocean's mountain ranges or valleys on Earth. There are globular clusters, ancient swarms of hundreds of thousands of stars orbiting like companions around the galaxy. There are star-forming nebulae, glowing clouds of gas where new suns ignite. There are supernova remnants, the expanding echoes of exploded stars. And weaving through all of it are the spiral arms themselves, regions where stars, gas, and dust gather more densely, curving gently around the core. Our solar system rides along with that motion, completing one slow orbit around the galactic center roughly every 230 million years. That means that since the age of the dinosaurs, the entire rise and fall of those ancient creatures, our solar system has completed only a single slow circuit around the galaxy. One orbit takes longer than all of human history many times over, and yet the Milky Way itself has been spinning for more than 13 billion years, completing rotation after rotation long before the Earth even existed. We belong to a galaxy that is not only immense in size, but profoundly old in time. At its center lies something truly extraordinary, the supermassive black hole known as Sagittarius A. This object contains about 4 million times the mass of our Sun, all compressed into a region no larger than Mercury's orbit. It's invisible to the eye, hidden behind curtains of gas and dust, but its presence reveals itself through the rapid orbits of nearby stars. Stars that move so quickly and so tightly around an unseen point that only a black hole of enormous mass can explain their motion. In 2022, the Event Horizon Telescope collaboration released the first image of the environment surrounding Sagittarius A, a glowing ring of hot matter circling a dark void. That dark center is the closest glimpse we can ever have of the black hole itself. Knowing that such an immense silent object sits at the core of our galaxy is both humbling and strangely beautiful. It feels almost like a heartbeat, an invisible pulse around which everything else slowly turns. Surrounding the disk and central bulge is yet another layer of the galaxy, the halo. This vast, faintly populated sphere stretches far beyond the visible spiral, holding scattered stars, ancient globular clusters, and something even more mysterious, dark matter. Dark matter does not shine, it does not glow, and it does not reflect. But its gravity holds the galaxy together. Without this unseen mass, the stars in the outer regions would simply drift away into space. Instead, a hidden framework provides the structure, shaping the motion of everything within it. In this quiet way, the Milky Way is part visible, part invisible, a reminder that even our cosmic home is only partly known. Up to now, we've been using measurements that feel enormous and abstract light years, billions of stars, billions of years. So let's slow down and anchor those ideas. Our sun, the warm star that lights our days and holds our planets in orbit, is just one among an estimated 200 to 400 billion stars inside the Milky Way. The range is wide because many stars are lost behind dust or too faint to count clearly. But even the lowest estimate is staggering. 200 billion suns, each one a furnace of light, many of them likely hosting their own families of planets. And if even a tiny percentage of those worlds are capable of supporting life, then the number of possible homes for consciousness within our galaxy becomes almost unimaginable. Yet for all this abundance, the stars are spread so far apart that our nearest neighbor, Proxima Centauri, sits more than 4 light years away. In human terms, that means even in a galaxy full of potential companions, the distances are so immense that meeting them would be extraordinarily difficult. The Milky Way manages to feel both densely populated and profoundly solitary at the same time, a glowing metropolis where every household sits thousands of trillions of kilometers from the next. As that thought settles, return for a moment to the image of yourself beneath the night sky. The soft, milky band you sometimes see overhead is your sidelong view through the galactic disk, your line of sight, passing through thousands of light years of stars. That shimmering ribbon is something only visible from inside the structure. If you could step outside the galaxy, a view we can only imagine, you would see the whole disk stretching calmly across space, slightly tilted, faintly luminous, spiraling outward with sweeping arms. Astronomers cannot physically leave the Milky Way, but by observing other spiral galaxies, they reconstruct what ours must resemble. In a sense, every photograph of a distant spiral is a kind of mirror held gently toward us, offering a glimpse of our cosmic shape. Telescope images show delicate arcs of starlight, dark lanes of dust curling like smoke, and glowing regions where new stars ignite. They're beautiful on their own, but their deeper meaning is that they help us envision the architecture of the galaxy we inhabit. And this isn't idle dreaming. Understanding our own galaxy's size and shape is essential if we want to place it within the far larger framework of the universe. The Milky Way is our reference point, our anchor, the first step in comparing local space to the cosmic ocean stretching beyond. To map this home, astronomers use many techniques. They study how stars move, they trace clouds of dust and hydrogen gas, and they use radio waves to see through the opaque regions that block visible light. One of the most remarkable tools is the Gaia mission launched by the European Space Agency. Gaia has charted the positions and motions of more than 1 billion stars, giving us the most detailed, three-dimensional portrait of the Milky Way ever created. With every new measurement, the picture sharpens, but the sheer size of the galaxy ensures that mysteries remain. The faint outer edges of the disk, the distant reaches of the halo, these are still only lightly sketched. Knowing even part of this map makes it astonishing that our solar system sits exactly where it does, nestled peacefully in the Orion Arm, far from the chaotic core, yet close enough to see the rich glow of the disk overhead. That position offers stability, gentle sunlight, and a night sky capable of inspiring questions like the one we're exploring tonight. To live inside a galaxy is something every star experiences, but to be a creature that can describe that galaxy, to measure it, comprehend it, and compare it to the larger universe, that is something rare and extraordinary. And as the idea expands in your mind, notice how the scale of the Milky Way begins to feel less overwhelming. 100,000 light years may sound impossibly large at first, but once you picture the spiral arms, the central bulge, the dark matter halo, and the black hole at the core, the galaxy begins to feel like a vast city with familiar districts, neighborhoods, and pathways. A place with structure, a place you belong to, a place you can almost imagine walking through star by star. You already know where you sit in relation to the galactic center. You know which direction the spiral arms extend. You know the disk turns gently, carrying every star, including our own, through its slow rotation. You know that the night sky is simply your neighborhood seen from the inside. With that understanding, you can finally open the door to the bigger question: if this entire structure is just the Milky Way, then how much larger is the universe that surrounds it? But before we drift outward into that immensity, let's remain here a little longer, floating in the quiet depth of our galactic home, allowing its size, its age, and its presence to truly settle in. The Milky Way is not just scenery, it is the cosmic architecture we inhabit every second of our lives. Its gravity cradles our solar system, its stars sprinkle our sky, its spiral arms shape the very pattern of the heavens. To recognize its vastness is to feel both small and protected, to sense that we are held inside something ancient and enduring. This is the home we belong to in the great cosmic night, and knowing that makes the step outward into the broader universe not frightening but meaningful. When we use the phrase our galaxy, we say it casually, as if the word galaxy is obvious and simple. It's a term many of us first heard as children, someone pointing upward and explaining that all the stars belong to a single enormous family. But if someone paused and gently asked you, what exactly is a galaxy? The answer would be more layered than it first appears. The word itself carries both clarity and mystery. It can be defined with physics, and yet fully appreciating it requires stepping back far enough to picture the architecture of space on its widest scales. Tonight, we'll unpack that question slowly, not like a textbook, but like a lantern being lit, one soft layer at a time, until the word galaxy feels grounded, vivid, and no longer distant. The simplest place to begin is with the stars. A galaxy is at its most visible level a magnificent congregation of stars held together by gravity. In the Milky Way's case, that means hundreds of billions of suns. Smaller galaxies contain far fewer. Giant galaxies may hold trillions. These stars aren't scattered carelessly. They form coherent structures, disks, bulges, halos that stay together for billions upon billions of years. Gravity is the quiet force that binds them, pulling each star toward all the others, while their orbital motion provides the balance that prevents collapse. Without gravity, these stars would drift apart endlessly, drifting like glowing embers caught in a cosmic breeze. But because gravity weaves them into a single system, they circle a shared center, tracing orbits far more expansive than anything in a planetary system. Yet stars alone don't tell the full story. A galaxy is also filled with clouds of gas and dust, the fertile material from which future stars are born. These vast clouds of gas and dust stretch across enormous regions of space, so thin and cool that our eyes cannot detect them. Yet they glow softly in infrared and radio wavelengths. Within these quiet expanses, gravity sometimes finds just enough of a foothold to begin pulling material inward, compressing it grain by grain until the pressure becomes great enough for nuclear fusion to spark. And in that moment, a star is born, a new drop of fire in the dark. A galaxy, then, is not simply a place where stars happen to gather. It is an engine of creation, a long running cycle in which stars emerge, shine, and eventually fade or explode, enriching the surrounding gas with new elements that will one day form fresh generations of suns. Within a single galaxy, you can find whole nurseries where newborn stars cluster together, glowing blue and intense, while in other regions, ancient stars drift quietly toward the end of their lives, dim and red. A galaxy carries both youth and age at once, constantly renewing itself on timescales far beyond human memory. But there is another ingredient, one stranger than any cloud or star, that defines what a galaxy truly is. Something we cannot see, but whose presence is undeniable. Dark matter. When astronomers track how galaxies spin, they discover a mystery. The stars near the edges orbit far too quickly for the visible mass to hold them. They should drift away. Instead, they remain bound, as though wrapped in an invisible cocoon of gravity. This unseen mass, silent, transparent, and pervasive, is what we call dark matter. It does not glow, reflect, or block light, yet its gravitational pull outweighs all the ordinary matter we can observe. Most of a galaxy's mass lives in this hidden halo, shaping its motion and maintaining its structure. Without dark matter, galaxies would unravel like loose threads. So, when we use the word galaxy, we are really describing a layered system. Bright stars, drifting gas, fine dust, and an enormous invisible sphere of dark matter holding it all together. And at the center of many galaxies lies another defining feature, a supermassive black hole. These beings, millions or even billions of times more massive than the sun, sit in quiet gravity at their galaxy's heart. Some consume surrounding gas and flare with tremendous energy, sending out jets that pierce space. Others, like the one in the Milky Way, rest in a calmer state, only stirring when a stray cloud wanders too close. Their existence hints at an intimate partnership. Galaxies and their central black holes appear to grow together, shaping each other across cosmic time. To describe a galaxy without acknowledging this central presence would be like describing a living creature without mentioning its heartbeat. And there is still one more layer to unfold a feature so fundamental that it shifts our understanding of what a galaxy truly represents. A galaxy is not a static island of stars. It is a dynamic community shaped by time, motion, and interaction. Galaxies collide, merge, and reshape one another in slow cosmic dances lasting billions of years. From afar, it looks violent, but in reality, the stars themselves almost never touch. Space is simply too vast. Instead, gravity stirs the orbits, pulls gas into new configurations, and triggers waves of star formation as entire galaxies blend into new forms. Our own Milky Way is not exempt from this quiet choreography. It has absorbed smaller galaxies in the past, their stars now woven invisibly into our halo. And far in the future, billions of years from now, it will merge with the Andromeda Galaxy, forming a new, larger system whose name we can only imagine. This intergalactic evolution reminds us that even structures as immense as galaxies are not permanent. They too change, grow, and transition just like everything else in the universe. All of these pieces, stars, dust, gas, dark matter, black holes, and slow cosmic interactions, come together to form what we casually call a galaxy. But the truth is deeper. A galaxy is a long, unfolding story of matter organizing itself across unimaginable distances and timescales. It is a self sustaining pattern, a gravitational ecosystem, a vast container in which complexity can arise. It is the setting that makes planets possible, chemistry possible, life possible. Without galaxies gathering matter into stable structures, the universe would be a cold, thin fog with no place for stars to burn or worlds to form. In a sense, a galaxy is the universe's way of gathering itself just tightly enough for consciousness to eventually bloom. As you let this idea settle, imagine again that you are lying beneath a quiet sky. Every point of light above you is part of this immense structure. Every faint glimmer, every soft blur of light belongs to a story billions of years old. And you are inside that story, not an observer outside the cosmos, but a participant within it. The atoms in your breath, your bones, your heartbeat were forged in ancient stars that lived and died long before Earth existed. You carry the memory of the galaxy within you, written in the elements that make your body work. When you think of galaxies, now try not to imagine something distant or unreachable. Think of them as the great cosmic homes in which matter organizes itself into shapes capable of wondering about their own origins. Think of them as the quiet architecture that makes your existence possible. So far, we've laid out the ingredients: stars, gas, dust, dark matter, and central black holes. But a galaxy is also defined by the way these ingredients arrange themselves. Structure matters. When astronomers look out into deep space, they see that galaxies come in different overall shapes. Some are spirals with sweeping arms that curve outward in graceful patterns. Others are more rounded and smooth, called ellipticals. Some are irregular, lopsided systems with no clear symmetry at all. Our own Milky Way belongs to a special class called barred spirals. At its center, a straight bar of stars stretches across the core, and from the ends of that bar, The spiral arms unwind like ribbons. These categories help us organize what we see, but in truth, every galaxy carries a unique history. Its shape is the result of countless interactions, mergers, and quiet stretches of time. Galaxies pass through one another, tug at each other, tear pieces away, and then slowly settle into new configurations. They are not frozen islands. They are evolving ecosystems, shaped both by their internal gravity and by the larger cosmic environment that surrounds them. To understand what a galaxy truly is, it can help to clarify what it is not. A galaxy is not just a loose crowd of stars passing in the same general region. It's not a momentary lineup of objects that happen to look close from our point of view. And it is definitely not the same thing as a constellation, the patterns we draw in the sky with our imagination. Constellations are two-dimensional illusions born from Earth's perspective. Their stars may be separated by enormous distances and are not physically bound together. A galaxy, by contrast, is a genuine three-dimensional structure, a gravitationally bound family of stars, gas dust, and dark matter that remains held together for billions of years. It is coherent, long lived, and connected at a level far deeper than a simple visual pattern. Another way to get a feel for what a galaxy is comes from thinking about scale. At the smaller end, there are dwarf galaxies containing perhaps a few 100 million stars. By everyday standards, that is unimaginably large. Yet compared to the truly gigantic galaxies, dwarfs are tiny. At the other extreme are massive systems with trillions of stars stretching hundreds of thousands of light years from side to side. Between these two extremes are galaxies, like the Milky Way, medium-sized spirals with a few 100 billion stars. Each type plays a role. Dwarf galaxies often orbit larger ones as companions, eventually being stripped apart or absorbed. Giants dominate the crowded centers of galaxy clusters, their gravity pulling in smaller neighbors over time. Across all this variety, the core idea remains the same. A galaxy is a system big enough and bound tightly enough to sustain itself over vast cosmic ages. Our understanding of what counts as a galaxy has not always been this clear. A little more than 100 years ago, astronomers were still arguing about the nature of the mysterious spirals seen through early telescopes. Were these swirling shapes simply clouds, nebulae within the Milky Way, or were they separate island universes lying far beyond its boundaries? The turning point came in the 1920s when Edwin Hubble measured distances to some of these spirals and discovered they were far outside our own galaxy. They were full-fledged galaxies themselves. That realization blew open our sense of scale. Suddenly, the Milky Way was no longer the entire universe, but just one member of a much larger population. Since then, with the help of powerful ground-based observatories and space telescopes, we've seen not just a few spirals, but billions of galaxies scattered across the observable universe. The word galaxy has become a fundamental unit when we describe cosmic structure as basic to the large-scale universe as stars and planets are to smaller scales. When you hold that word in your mind, now try to let it feel less like technical jargon and more like a word for a kind of place. A galaxy is a home for stars. a cradle where new light is born, a container that carries history almost all the way back to the beginning of time. It's a balance between gravity and motion, between luminous matter and invisible mass, between order and turbulence. It's not simply an object we point a telescope at. It is the environment in which every star you know exists. And on the grandest scales, the universe itself can be thought of as a web of galaxies. They are the building blocks, the bricks from which the cosmic structure is assembled. When you return in your thoughts to the Milky Way, you can now see it not just as our galaxy, but as one particular example of this broader idea, a barred spiral containing hundreds of billions of stars wrapped in a halo of dark matter, threaded with gas and dust, and anchored by a supermassive black hole at its core. That description is enough to recognize the Milky Way as a galaxy. But to appreciate the idea fully, picture an Andromeda, our nearest major neighbor, drifting toward us across the cosmic dark. It is another grand spiral larger than our own, with its own central black hole, its own sweeping arms, its own immense population of stars. Then imagine the much smaller Magellanic Clouds, faint companions that orbit our galaxy like quiet satellites. They too are galaxies, even though they are tiny. By comparison, they meet the same criteria: self contained systems held together by gravity, enduring across billions of years, instead of dissolving into the void. If you could lift your perspective beyond the Milky Way, you would see other galaxies speckled across space like distant lanterns. Some drift in solitude, others huddle in small groups. These groups gather into clusters, and clusters form even larger arrangements. Yet, no matter how far outward you zoom, the basic building block of the visible universe remains the same: the galaxy. Asking what a galaxy is, then, is really asking what the fundamental unit of cosmic architecture looks like. Without galaxies, stars would still exist, but not in grand, long lived structures. Without galaxies, the universe would appear as a scattering of isolated sparks, not the richly patterned tapestry we observe. It is the presence of galaxies that gives the cosmos shape, pattern, and continuity. Let your thoughts return for a moment to that simple word galaxy. It slips off the tongue so easily that we sometimes forget how much it contains. Inside it are billions of suns and the worlds orbiting them. It holds the full cycle of cosmic life: birth, brilliance, decline, and renewal. It carries the invisible weight of dark matter shaping its form from the shadows. It remembers collisions and mergers in the motions of its stars. It comes in many shapes: spiral, elliptical, irregular, but all of them stretch across tens or even hundreds of thousands of light years. To define the word is not to limit it. It is to recognize how much meaning it truly carries. When the night is quiet and you imagine the stars overhead, let that meaning settle gently. A galaxy is not a distant idea separate from us. It is the very structure that holds our existence. Knowing what it is also tells you where you are. And once that foundation feels steady, once the word becomes less mysterious and more like a description of home, you can step outward again with a clearer sense of direction. When most people think of the Milky Way, they imagine the faint milky glow that slides across the night sky. That soft band of light is beautiful, but from our vantage point within the disk, it hides more than it reveals. Trying to infer the shape of the Milky Way from Earth's surface is like trying to determine the layout of a forest while standing deep among the trees. You sense the density around you, but the overall pattern is hidden. For centuries, astronomers faced the same limitation. Only within the last 100 years have we pieced together a more complete picture of our galaxy's true form. Tonight, we let that picture unfold slowly, turning the Milky Way from a hazy streak of light into something more like a map. Astronomers classify the Milky Way as a barred spiral galaxy. Imagine a vast disk with long curving arms spiraling outward from a bright central bar of stars. If you could rise far above the galactic plane, you would see a luminous core, a slender bar stretching across it, and elegant arms unfurling around it like cosmic ribbons. The entire disk spans about 100,000 light years in diameter and is only about 1,000 light years thick, a massive, delicate sheet of starlight. That thinness is the reason the Milky Way appears as a narrow, glowing band from Earth. Looking along the disk, your line of sight cuts through countless layers of stars. Looking above or below the disk, you see far fewer. At the center lies the bulge, a rounded, densely packed region filled with older stars, thick clouds of gas, and the supermassive black hole known as Sagittarius A. The bulge isn't perfectly spherical, it is slightly elongated, contributing to the bar like structure that defines our galaxy's heart. This bar stretches roughly 27,000 light years across the core, and from its ends, the spiral arms unwind. These arms aren't rigid structures, they're regions where stars and gas are more densely collected. As stars orbit the galaxy, they drift into and out of these regions, creating the illusion of permanent arms, even though the individual stars are constantly moving. Astronomers have traced several major spiral arms sweeping through the Milky Way, though determining their exact layout is challenging because we are observing everything from inside the structure itself. Still, patterns emerge. Among the most prominent arms are the Perseus arm, the Scutum Centaurus arm, and the Sagittarius arm. Our own solar system rests not in one of these grand spirals, but along a smaller offshoot, known as the Orion arm, sometimes called the Orion spur, nestled between the larger Perseus and Sagittarius arms. From our position, about 27,000 light years from the galactic center, we sit roughly halfway between the middle and the outer edge of the disk. It is a remarkably calm region of space, far enough from the turbulent core to avoid the hazards of densely packed stars, yet not so distant that the environment becomes too sparse. In cosmic terms, it is a quiet and comfortable neighborhood. The galactic disk itself is layered rather than uniform. A thin disk holds most of the stars and the gas where new stars continue to form. Surrounding it is a thicker, older disk populated by stars with different motions and histories. Beyond both lies the halo, a vast, roughly spherical zone extending far above and below the disk. Within this halo float ancient globular clusters, dense swarms of hundreds of thousands of old stars that orbit the galaxy, like tiny companions. And woven through this halo is the greatest portion of the Milky Way's dark matter, an unseen mass that outweighs all the visible stars. Without this invisible framework, the galaxy would lose its cohesion. The stars in the outer disk would drift apart instead of moving in their surprisingly fast orbits. Their motion is one of the strongest clues that dark matter is real even if we cannot yet observe it directly. The scale of all this defies the everyday world. 1 light year is nearly 10 trillion kilometers. Crossing the Milky Way at the speed of light would require about 100,000 years, and at the pace of our fastest spacecraft, the journey would take billions. Within this immense disk, however, hundreds of billions of stars are scattered across the spiral arms like grains of sand arranged in elegant curves. If you could rise above the galaxy and look down, you would see a faint glowing disk, brighter toward the center and thinner toward the edges, streaked by lanes of dark dust. The whole structure would look both immense and fragile, a luminous pinwheel quietly rotating in the vastness. The Milky Way's size is not just a fact of geometry, it is also a measure of time. Our solar system completes a single orbit around the galactic center roughly every 230 million years. In the entire 4.5 billion year history of Earth, our planet has made only about 20 such revolutions. When dinosaurs roamed the planet, the solar system occupied an entirely different region of the galaxy. Continents shifted oceans, formed species, rose and vanished, and all the while our system drifted steadily along its galactic path. Each lap is so long that entire eras of life unfold in the time it takes to complete one circuit. In that sense, the Milky Way's size can be read not only in kilometers or light years, but in ages. The galaxy is not frozen in time either. Its shape and boundaries are constantly being influenced by gravitational encounters. Even now, the Milky Way is absorbing smaller dwarf galaxies, pulling their stars into long sweeping streams that lace the halo. And in roughly 4 billion years, the Milky Way will meet Andromeda in a vast slow motion collision. Over billions of years, the two spirals will merge into a new, larger elliptical galaxy. For the moment, though, the Milky Way remains the elegant barred spiral we describe, stable enough to map, yet always evolving. Because we cannot leave the galaxy to view it from the outside, our understanding must come from indirect methods. Astronomers chart the positions and motions of stars, trace the outlines of gas clouds with radio telescopes, and analyze the way dust absorbs and scatters light. Together, these clues reveal the general structure of the disk. The Gaia spacecraft has been transformative in this effort, measuring the motions and distances of more than 1 billion stars with remarkable precision. Its data give us the clearest picture yet of the galaxy's vast architecture. With data like this, astronomers can trace the sweep of the spiral arms, estimate the thickness of the galactic disk, and even pick up subtle waves and ripples, scars left behind by ancient encounters with passing galaxies. Slowly, detail by detail, a map emerges. It isn't perfect and it isn't finished, but it is the clearest portrait of our home galaxy we've ever had. The measurements that describe the Milky Way are precise, Yet they carry a softness too, because a galaxy does not end the way a planet does. There is no edge, no cliff, no sudden boundary. Instead, the starlight thins. Gas becomes more sparse, and gradually, what belongs to the galaxy blends into the quiet darkness between galaxies. So, depending on what you choose to include the Milky Way, changes size. The bright disk, what we see in visible light, is about 100,000 light years across, but the dark matter halo surrounding it may stretch nearly 300,000 light years or more. In that sense, our galaxy is far larger than its luminous stars reveal. Its true reach hides inside an invisible cocoon of mass. Thinking about these scales can feel dizzying at first, but if you let the idea settle slowly, there is a strange comfort in it. The Milky Way is not some distant, unfamiliar object. It is the container of our sun, our planet, and every chapter of Earth's history. Its spiral arms are the rivers along which stars are born. Its halo is the quiet shield holding everything together. Its central bar and bulge form the gravitational anchor around which all of us orbit. To understand the galaxy's shape is to understand the architecture of the place we inhabit. To grasp its size is to feel the true stage on which all of human existence has unfolded. Picture yourself again beneath a dark sky. You look up at that pale streak of light, the Milky Way. But now let your imagination expand. Instead of a thin band, imagine the entire disk unfurled above you, 100,000 light years wide, spiral arms curling outward like slow cosmic waves, hundreds of billions of stars scattered throughout. Imagine your own sun as one tiny spark drifting along the Orion arm, and imagine a vast unseen halo surrounding the whole system 3 times wider than the disk made of faint stars and dark matter wrapping the galaxy in an invisible sphere. Suddenly, the night sky becomes more than scattered pinpoints. It becomes the interior view of a sprawling spiral world. A home so broad it takes roughly 230 million years for our sun to complete a single lap around its center. As that image settles in your mind, the Milky Way becomes less mysterious. It changes from a poetic glow into something tangible, a disk thin and wide with a bar at its core and arms extending in graceful arcs, a structure hundreds of thousands of light years across when you include its halo, a galaxy made of stars, dust, and vast amounts of unseen matter, a system alive with motion shaped by gravity time and ancient interactions. It is immense, but no longer unreachable. It is vast, but also familiar, because it is the place where we live. And knowing the shape of your home brings a certain quiet peace. All of these pieces gradually assemble into a kind of mental atlas. And even though we will never rise far enough above our own galaxy to see its shape with our own eyes, we can still turn that map gently in our imagination until it begins to feel familiar and lived in. So let's linger a moment longer with the picture we've built. A barred spiral stretching roughly 100,000 light years from end to end, threaded with arms and dust lanes, wrapped in a vast halo, anchored by a black hole, and filled with hundreds of billions of suns. This quietly and undeniably is home. Once that shape settles into place, it feels natural to let our awareness drift outward as if stepping off the front porch to look at the neighborhood that surrounds our cosmic house. A single galaxy may be enormous, but it is never truly alone. It belongs to a small community, a gravitational family, where galaxies drift, circle, and interact over spans of time so long they make human history feel like a passing breath. As we take in this broader view, the Milky Way becomes one member of a much larger gathering, and the scale of everything stretches once more. Tonight we'll walk slowly through that neighborhood, beginning with the closest companion and moving outward along the threads that weave galaxies into greater structures. The nearest major companion to the Milky Way is the Andromeda Galaxy. It is the closest large spiral to us bigger than the Milky Way and rests about 2 million light years away, a distance overwhelming to imagine, yet in the vast geometry of the universe, it makes Andromeda feel almost near. If the Milky Way were a solitary home, Andromeda would be the next house across a wide, quiet field, far but still visible through the trees. And remarkably, it is visible to the human eye. On dark, clear nights, Andromeda appears as a faint, ghost like smudge suspended in the sky. Viewed through telescopes, it reveals its true nature, another barred spiral with sweeping arms, rich dust lanes, and hundreds of billions of stars of its own. There is something deeply grounding in knowing that this tiny blur above you is not a cloud or a trick of light, but an entire galaxy, almost a twin, to our own hanging silently across the void. Around both Andromeda and the Milky Way orbit smaller companions, dwarf galaxies that serve as gentle reminders that even giants rarely travel alone. Two of the most famous are the large and small Magellanic Clouds, visible from southern latitudes as soft, irregular glows. These dwarfs are being slowly shaped by the Milky Way's gravity. Threads of stars and gas stretch from them like cosmic tide marks, evidence of an ongoing gravitational dance between the small and the immense. Dozens of faint dwarfs circle the Milky Way like scattered lanterns, some only discovered in the past few years as deep surveys revealed their subtle presence. Andromeda has its own cloud of companions, as well, forming a second family across the intergalactic distance. Together, these collections, the Milky Way, Andromeda, and all their satellites, form what astronomers call the local group. This collection has an official name. The local group, a small gravitational community of more than 50 galaxies linked together across millions of light years. Most of its members are tiny, dim dwarf systems that drift quietly around the outskirts, but two giants dominate the scene, the Milky Way and Andromeda. Between them stretches a long gravitational tension, a slow, ancient pull that is gradually drawing the two galaxies toward one another. In roughly 4 billion years, these spirals will meet and blend into a single, larger system. For now, they inch closer at about 100 kilometers per second, a speed that feels tremendous to us. Yet in the vastness of intergalactic space, it is the pace of inevitability unfolding over aeons. That gentle pull, steady and unhurried, is part of what makes the local group feel like a true cosmic neighborhood. Its galaxies are not free to wander off. They are gravitationally connected, moving through space in long, looping trajectories that only become clear when measured on the scale of billions of years. In the grand scheme of the universe, however, the local group is modest. It stretches roughly 10 million light years from end to end, a tiny patch in the much larger cosmic map. Within that span, the galaxies are sprinkled sparsely, each separated from the next by enormous oceans of emptiness. If you could drift far enough away to look back, the local group would appear as a loose gathering of glowing islands suspended in darkness, two bright spirals at the center, and dozens of faint companions scattered around them like embers from a distant fire. It is not a bustling metropolis of galaxies, but more like a quiet rural region where each settlement is isolated by long stretches of night. This spaciousness is part of the nature of galactic structure. Even when galaxies cluster, the distances between them remain immense, reminding us that in the architecture of the cosmos, silence and emptiness carry just as much weight as light and motion. Beyond the local group lies the next layer of our surroundings. The entire group sits within a broader arrangement known as the local sheet, a flattened, gently curved plane containing several nearby galaxy groups. If the local group is our home, the local sheet is the road our home sits on. Along this cosmic street lie other galactic families, the M81 group, the Centaurus group, and others, each with their own large spirals, their own dwarf companions, and their own quiet dramas playing out across millions of years. Together, these nearby groups create a pattern that is far from random, a quiet geometry shaped by gravity, by the slow expansion of space, and by the hidden scaffolding of dark matter. The local sheet stretches roughly 30 million light years across and within this flattened region. The galaxies drift with only gentle motions relative to one another. Over billions of years, this slow choreography creates a sense of calm stability, like leaves floating together on a vast, steady current. A little farther out from our small collection lies one of the most important landmarks in our region of the cosmos, the Virgo cluster. It sits about 65 million light years from us and contains more than 1,000 galaxies, an immense congregation compared to the quiet handful in our local group. If our home is a village, the Virgo cluster is a luminous metropolis. Spiral galaxies, elliptical giants, dwarfs, and irregulars all live there, packed together more tightly than anything in our immediate surroundings. Some of the galaxies in Virgo are titans, trillions of stars gathered into smooth elliptical shapes. Others resemble the Milky Way, winding with dust lanes and spiral arms, but caught in the gravitational web of the cluster. The entire structure is held together not only by the mass of its galaxies, but by an even larger reservoir of dark matter, a reminder that the visible universe is only the thin surface of a deeper, invisible design. As astronomers mapped clusters like Virgo and groups like our own, a new picture emerged, one that stretches across unimaginable distances. Galaxies are not sprinkled randomly through space. They gather into long filaments, sheets, and walls, creating enormous structures that span hundreds of millions of light years. Between these bright threads lie vast voids, nearly empty regions, where only a few galaxies drift in isolation. Together, these features form what scientists call the cosmic web, a sprawling network that looks almost organic, like the branching of trees or the veins beneath a leaf. Galaxies are the bright intersections. Groups are the knots, clusters are the hubs, and all of them are connected by the faint, unseen strands of dark matter and diffuse gas that thread through the universe. This quiet journey through our cosmic neighborhood is more than a sequence of distances and names. It is a way of understanding our place in the hierarchy of existence. On the smallest scale, we belong to our solar system orbiting a single star. One step wider, we are citizens of the Milky Way, circling its center as the galaxy slowly turns. Wider still, we live in the local group, bound in a long gravitational bond with Andromeda and dozens of smaller companions. Beyond that, our local group nestles inside the Virgo supercluster, which itself is just a modest fragment of an even grander structure, often called the Laniakea supercluster, a sprawling region containing on the order of 100,000 galaxies. Each layer we step through from solar system to galaxy to cluster to supercluster expands our sense of scale while also grounding us more deeply in the realization that we belong to something intricately organized and vast. The universe does not grow emptier as we zoom out, it grows more connected. The word neighborhood can make all of this sound almost cozy, as if the cosmos were small enough to stroll across. In reality, it is a metaphor, a way of translating unimaginable distances into something the mind can hold. Just as on Earth, where some houses sit close together and others are separated by wide fields, some galactic groups are dense and busy, while others are sparse and quiet. Some contain huge luminous galaxies. Others are filled mostly with faint dwarfs. And just like human neighborhoods, these cosmic communities are not sealed off from one another. They interact, tug one another with gravity, and slowly reshape each other over billions of years. Our corner of the universe is defined not only by which galaxies are nearby, but by the subtle ways their gravity interlocks, pulling them into long term patterns that will continue long after humanity is only a memory. When you stand beneath the night sky, you are seeing only the innermost layer of this structure. Every star your eyes can pick out belongs to the Milky Way. That pale band arching overhead is just the dense part of our own disk. Yet beyond that ribbon of light, out past the limit of naked eye vision, lie our neighbors. Andromeda drifting toward us, the Magellanic Clouds circling quietly, dozens of dwarf galaxies orbiting unseen like distant houses with their lights turned low. Farther still, clusters and superclusters, strands of the cosmic web, and the great empty voids between them, all arranged in patterns so large that language can only hint at them. And still, the word neighborhood feels right, because whether we talk about the home next door or the galaxy next door, the feeling of belonging to a shared environment remains. We are not floating alone in an empty universe. We inhabit a community silent, ancient, and unimaginably wide, but a community nonetheless. As this slow walk through our surroundings comes to a pause, the structure of our cosmic address becomes clearer. The Milky Way is our immediate home. Andromeda is the grand neighbor across the way. The many dwarf galaxies are like smaller homes clustered nearby. Together, they compose the local group, which rests along a broader sheet of galaxies, which in turn connects to clusters' filaments, and finally, to the vast Laniakea supercluster. Each step outward increases the distance, but it also increases the sense of connection. A galaxy is not a true island. It is a node in a web that spans the entire observable universe, a neighborhood so immense that at some point the neighborhood and the universe become the same thing. When we speak of galaxies, the numbers can flood the mind. Hundreds of billions of stars in a typical large spiral, trillions of stars in giant ellipticals, billions upon billions of galaxies spread across space. It is easy for the imagination to slip and lose its footing. So instead of trying to hold everything at once, we can soften our focus and come back to a single, simple question. Before we worry about the whole universe, what can we say about the stars in just our own galaxy? Counting the stars of the Milky Way is not like counting grains of sand in a jar. It cannot be done by pointing a telescope and marking them off one by one. It is an exercise in inference, in measurement, and in careful estimation, a blend of data and imagination working together to sketch the shape of our stellar home. All of these variations affect how astronomers estimate the total number of stars. A dense region will contain far more stars per cubic light year than a quiet outer region, so each part of the galaxy must be weighted differently. It is like trying to estimate the number of lights in a vast city when some districts shine brightly and others lie almost dark. You count carefully in each district, adjust for brightness, and then combine the results into a single estimate. It is intricate work, but it turns the overwhelming into something we can describe. Modern missions like Gaia, which measures the positions and motions of more than 1 billion stars, have transformed these estimates. Gaia does not see every star, but it sees enough to trace patterns, how stars cluster, how they drift, how their density changes from arm to arm. With this data, astronomers refine the models, updating the population count of the Milky Way with greater accuracy each year. Even so, the numbers remain estimates because our galaxy is simply too large and too dust filled to reveal every star directly. And yet, there is something beautiful about this uncertainty. The exact number doesn't change the feeling of standing beneath the night sky. Whether there are 200 billion stars or 400 billion stars, the difference is more poetic than practical. What matters is the recognition that our galaxy is full beyond full with suns. A vast ocean of light, most of it invisible to our eyes, but no less real. A reminder that what we see is only the surface of something far richer. As you let this settle, imagine for a moment that you could dim the galaxy's bright stars and reveal only the faint ones. A quiet glow would fill the sky, soft and even like the embers of an ancient fire. Now imagine brightening only the most massive stars, the blue giants, whose light crosses thousands of light years. The sky would sparkle with fewer points, but each one would blaze with intensity. The Milky Way contains both extremes and everything in between. Its population is not uniform, but layered, bright, dim, newborn, dying, woven together into a living tapestry. This brings us to one more important point. When astronomers estimate the number of stars, they are not only counting what currently exists, they are also tracing the galaxy's history. Stars are born, they live, they die. Supernovae enrich the galaxy with heavy elements, and new stars rise from that enriched gas. The Milky Way has been forming stars for billions of years and will continue to do so for billions more. The number of stars today is only one frame in a much larger film, and we happen to be witnessing it from a small, quiet corner called the Orion Arm. Thinking of the Milky Way this way turns the idea of counting stars into something almost meditative. You begin with the glowing points above you. Then you imagine the ones hidden behind dust. Then you picture the red dwarfs too faint to notice. Then you extend your imagination into the bulge, the halo, the arms. And slowly the mind fills with a sense of scale that is both enormous and surprisingly gentle. You don't need the exact number to feel the meaning. The galaxy holds hundreds of billions of stars. Your sun is one of them. Your atoms were forged in the heart of another. Each breath you take is in some distant sense part of a cosmic recycling matter born in fire, now inhaled into lungs that evolved on a tiny planet orbiting a quiet yellow star. And so the act of counting the stars becomes more than mathematics. It becomes a way of remembering where we are, a way of placing ourselves within a galaxy so vast that even its smallest estimates leave the imagination trembling. And yet, instead of fear, the feeling that arises is often calm, because to know that we live inside a galaxy of such magnitude is to recognize that our worries, our thoughts, our lives unfold within a much larger, peaceful rhythm, a rhythm measured in billions of years and hundreds of thousands of light years, a rhythm that continues gently whether or not we are aware of it. And perhaps that is part of its charm. The uncertainty adds a softness to the mystery, reminding us that some things are meant to be felt rather than fully counted. The Milky Way keeps a portion of its light tucked behind curtains of dust, behind distances so great that even our finest instruments struggle to pierce them. And in that veil of the unseen, the galaxy keeps its sense of wonder. Still, the act of trying to count the stars teaches us something meaningful. It shows us how astronomers piece together the invisible using fragments of the visible. It shows us how pattern, motion, brightness, and mass can be woven into a picture of the whole. And it reminds us that even though we occupy a single solar system on a single arm of a single galaxy, we have the tools and curiosity to take the measure of an entire cosmic city. When you stand beneath the night sky and look up, you are seeing only the barest surface, just the brightest lights shining through the atmospheric window above you. Yet the reality hidden behind that view is immense. Hundreds of billions of suns, each with its own history, its own planets, its own possible stories. You are looking at the faintest hint of a crowd so large it seems almost impossible. Imagine for a moment that you could lift the dust from the galaxy, sweep it aside like a thin fog. The sky would erupt into brilliance. Every patch of darkness would fill with stars. There would be no empty spaces, only waves of light stretching away in every direction. The Milky Way would reveal itself not as a quiet band, but as an ocean of suns. And still, even that vision would not include them all. The galaxy extends far beyond what our eyes allow us to sense, fading gradually into the halo, into the outskirts where stars grow sparse, but never quite vanishing. Counting them all with perfect precision would be like counting every drop in the sea. You could attempt it, but the deeper you go, the more you realize that the fullness of the ocean is understood not by tallying each drop, but by feeling the vastness of the water itself. The same is true here. The value in counting stars lies not in reaching an exact total, but in what the effort reveals. It shows us how enormous our galaxy truly is. It shows us that our sun is one among hundreds of billions, and it allows us to sense quietly, gently, that we are part of something much wider than our daily lives suggest. So the next time you look upward, remember the 6,000 stars you can see with the naked eye are a whisper, a fraction, a shimmering clue. Behind that whisper lies a cathedral of light, a population of suns so vast that even our best estimates only circle around the truth. And yet, that partial understanding is enough. It lets us stand here on our small world, breathe steadily, and feel a calm kind of awe. Because in the end, the exact number doesn't matter. What matters is knowing that the galaxy is full, that it is vibrant, ancient, and alive with starlight, and that somewhere within its hundreds of billions of suns, one small star warms a small planet where a mind like yours can look upward and wonder. And yet, even with all that hidden complexity, we can still speak about it in a meaningful way. We can draw loose boundaries, give it a size, and say with confidence that hundreds of billions of stars share this great spiral home with us. That balance between never knowing every last detail and still knowing enough to describe the whole is one of the quiet joys of astronomy. It reminds us that the universe is not a riddle we must completely solve, but a vast landscape we are allowed to explore, one careful estimate at a time. If just this single galaxy holds that many suns, it's natural to wonder what happens when we place the Milky Way alongside billions of other galaxies scattered across the universe. The numbers rise and rise until they slip beyond anything our minds can truly picture. But before we leap out to that scale, it's gentle and wise to linger here a bit longer right where we are in our own local sea of stars. Every point of light you see is a sun. Every sun has its own path, its own possible planets, its own quiet history. Together, they weave the luminous body of the Milky Way. We may never count them one by one, but sensing their sheer abundance changes how we feel about our address in space. We are not drifting alone in a dark void. We are immersed in an ocean of starlight so rich that even the word billions sounds too small to hold it. When you imagine the Milky Way, it's natural for the mind to sketch a kind of outline around it, the way we look at a map and see a country enclosed by neat borders. Clear edges make things easier to grasp. But galaxies aren't built that way. There is no glowing fence at the rim of the Milky Way, no crisp line where stars suddenly stop and emptiness begins. Instead, the galaxy softens at the edges, stars become fewer, gas grows thinner, the bright disk fades into a more diffuse halo, and beyond that, the difference between inside the galaxy and out in intergalactic space becomes less obvious. So, asking where the Milky Way ends turns out to be a deeper question than it first appears. It sounds simple, but the more you sit with it, the more subtle it becomes. Tonight, we can move through that question slowly, looking at how astronomers try to define an edge, what they mean when they talk about the size of the Milky Way, and what lies in the vast, quiet spaces between one galaxy and the next. The most natural place to begin is with the disk itself. Our galaxy is a barred spiral, and its main stellar disk stretches to roughly 100,000 light years across. This is the region where most of the stars and gas reside pressed into a thin, rotating plane with spiral arms sweeping outward from the central bar like gentle swirls in a cosmic whirlpool. They are not rigid objects with clean borders. They are living, evolving systems whose boundaries fade gradually into the darkness around them. Just like a cloud dissolves into the sky or a coastline blends into the sea, a galaxy softens as it stretches outward, its light thinning into the deep until there is no moment, no single point where you can truly say, here it stops. And in that softness, something gentle and profound becomes clear. The Milky Way does not end so much as it transitions into the vastness beyond it. The idea of a blurred boundary is not a flaw in the definition. It's a quiet reminder that the universe rarely deals in sharp lines. Gravity weakens, gradually light fades, gradually stars thin gradually. Everything dissolves into something larger. The galaxy's edge then depends on what you're looking for. If you're measuring light, the disk seems to end around 100,000 light years. If you're measuring stars, the halo pushes that boundary outward to several 100,000 light years. If you're measuring gravity, the virial radius at 250,000 light years becomes the practical frontier. If you're measuring dark matter, the true influence of the Milky Way spreads even farther, possibly up to 600,000 light years. There is no single answer because the Milky Way is not a single thing. It is layers upon layers, bright stars, dim stars, dust, gas, ancient clusters, and a vast invisible sea of dark matter, all interwoven. Each layer reaches farther than the one beneath it, like a series of soft shells. And beyond all of those layers lies intergalactic space, a realm so empty that you could travel millions of light years without encountering a single bright star. Yet even that emptiness is full of subtle influences, gas drifting through the void threads of dark matter, connecting galaxies into filaments, the faint pull of neighboring systems. The Milky Way's edge is not a wall. It is a fading, a gentle dimming of light, a loosening of gravity's hold, a place where stars wander from belonging to drifting. In that sense, the galaxy's boundary mirrors something human. We also live in soft edges between who we were, who we are, and who we will become. We are not defined by sharp lines, but by gradual changes, quiet transitions, expanding awareness. And knowing that the galaxy is not confined by rigid borders makes the next step outward even more meaningful. Because once we accept that our home is a fading spiral with no clear edge, we are ready to place it inside a universe that is even less bounded, even more fluid, even more vast than anything we've described so far. Whenever you're ready, we can drift gently onward from the edge of the Milky Way into the structure of the universe itself. They are not rigid structures cut cleanly out of the dark with crisp borders. Instead, galaxies are living systems shaped slowly by gravity time and the quiet push and pull of their surroundings. Stars are born in the thin disk, migrate outward into the halo, and sometimes drift so far that they slip from the galaxy's grasp entirely. Gas flows inward, is blown outward, torn away during encounters, and replenished by the final breaths of dying stars. Their halos, vast and invisible, melt softly into those of neighboring galaxies. The Milky Way doesn't stop the way a cliff does. It fades like walking away from a distant fire, its glow dimming step by step until it becomes part of the night itself. This leads to something subtle but fascinating. The boundary of the Milky Way is not identical for every observer. From the surface of Earth, the galaxy presents itself as a pale, milky ribbon. To human eyes, its edge is simply the point where the stars blur into darkness. A telescope shifts that edge outward. A radio telescope shifts it even farther because it can trace the faint whisper of hydrogen gas in places where no stars shine. Gravitational measurements expand it farther still, stretching the galaxy out to the unseen limits of its dark matter halo. Each tool draws its own outline, not because the galaxy itself changes, but because our perception deepens. In this way, the boundary of the Milky Way is shaped as much by our instruments and perspective as by the galaxy's true extent. A helpful comparison is Earth's atmosphere. Where does the atmosphere end? Near the ground, the air is thick and familiar. Higher up, it thins. Far above that, planes fail, and astronauts float weightlessly. Air still exists in trace amounts, but depending on the purpose, different definitions mark different edges of space. Some say 100 kilometers, others place it higher. Yet none of these boundaries represent a hard stop. The air simply diminishes until it blends into vacuum. The galaxy behaves in the same way dense regions, where stars crowd together, quieter regions, where they thin out, and an outer realm where the glow softens until it merges with intergalactic space. To ask where it ends is to accept that the answer depends on your definition. This gentle fading is not only structural, it is historical. Over billions of years, the Milky Way has grown by gathering smaller galaxies into its embrace. Their stars have been pulled outward and upward into the halo. Trails of stars, remnants of ancient mergers, still wind around the galaxy like faint celestial rivers arcing far beyond the bright disk. These stellar streams are evidence that the Milky Way is still evolving. It is still consuming, still stretching, still reshaping itself. In this sense, the galaxy's boundary is never fully settled because the galaxy itself is an ongoing creation, a slow cosmic work in progress, expanding, absorbing, and transforming across the ages. Thinking about the edge of the galaxy also softens how we think about our own place inside it. When we picture the Milky Way as a sharply defined disk with a clean outer rim, it's easy to imagine the solar system tucked neatly somewhere within safely contained. But when we imagine the galaxy as a gradually thinning structure, stars fading outward, gas trailing off gravity, loosening bit by bit, the boundary between inside and outside becomes far less rigid. Instead of living inside a sealed enclosure, we become part of a long, gentle continuum stretching into the greater universe. The Milky Way doesn't stop and then hand the cosmos over to something beyond it. It blends into everything around it, merging so smoothly that any dividing line becomes more symbolic than real. There's something comforting about that. Humans tend to seek clear edges, boxes, borders, categories, because they make the world feel simpler. But the universe doesn't honor those lines. It is built from gradients, slow transitions, and overlapping regions. The outskirts of galaxies are soft. The boundaries of clusters are soft. Even the boundary of the observable universe is not a wall, but a horizon defined only by the travel time of light. Everywhere we look, the cosmos avoids sharp corners. And instead of being limiting, this openness is liberating. It tells us that reality is far larger and more fluid than our definitions allow. As we rest with that idea, the Milky Way shifts from being a static picture to feeling more like a living organism. Its disk rotates with patient elegance. Its spiral arms sweep outward in slow arcs. Stars circle the center in their ancient paths. The halo expands invisibly around us. Stellar streams, faint remnants of long ago collisions, wrap around the galaxy like threads of memory. Gas clouds collapse and ignite, forming new suns. The supermassive black hole at the core anchors the entire system with quiet, immense gravity. None of these features end cleanly. They blend, overlap, and evolve. Asking where the galaxy ends is a little like asking where a breeze stops or where a flame's glow dissolves into the night. It never truly ends. It simply thins out until it becomes part of everything else. The Milky Way is not a container with walls. It is a structure shaped by motion and gravity, a disk, a bulge, a halo, and a sphere of influence that gradually weakens with distance. It ends in the practical sense where its gravity can no longer hold stars in orbit, where objects drift free, where its light and gas dissolve into the intergalactic medium. But even beyond that point, its influence lingers, overlapping, with Andromeda's halo blending into the broader structures of clusters and connecting through dark matter filaments that stretch across cosmic space. Its edge is not an ending. It is a transition zone, a subtle handoff between one structure and the next. And in that transition, we glimpse the deeper architecture of the universe, a universe not made of separate isolated islands, but of interconnected forms, each one dissolving softly into the next part of a single, continuous cosmic web. When we paused last time, we were sitting with the thought that the Milky Way doesn't end cleanly, that its edges blur and dissolve rather than terminate. And once that picture settles, a new curiosity naturally rises. If our galaxy fades outward, like the dimming edge of a lantern, then what lies in the vast gulf between one lantern and the next? What fills the darkness between galaxies? When we stand beneath the night sky and see the Milky Way stretched like a luminous river, or catch a faint glimpse of Andromeda's pale glow, it's easy to imagine the universe thick with stars, as though the entire sky were crowded and overflowing. But that impression comes from being inside a galaxy, immersed in a swarm of suns. Step outside in your imagination, lift yourself beyond the Milky Way's disk, and the picture changes completely. The light thins, the distances widen, the silence between galaxies becomes almost immeasurable. Tonight, let's wander into that silence slowly, one breath at a time, letting the emptiness open itself without fear or hurry. The first truth we meet is distance, distance so large it slips beyond the reach of instinct. Andromeda, our nearest large neighbor, sits roughly 2.5 million light years away. That is the closest major galaxy, and yet the number itself stretches the mind like a horizon we cannot touch. Light, the absolute speed limit of the cosmos, takes more than 2 million years to cross that gulf. The photons that touch your retina when you look at Andromeda began their journey long before the first human walked the Earth. If we tried to cross that distance with our fastest spacecraft, the journey would take tens of billions of years, far longer than the age of the universe. In cosmic language, Andromeda is nearby. In human language, it is impossibly distant. What lies between us and that neighbor is not a sea of stars, not a tangle of planets or swirling dust, but a profound spaciousness. And yet, even this space, this vast dark expanse, is not absolute emptiness. Between galaxies, the cosmos is not a perfect vacuum. Scattered across those distances are stars that once belonged to galaxies, but were flung outward during gravitational encounters. Some were torn from their homes during galactic mergers. Others drifted free after long, slow tides stretched their orbits until they escaped. These solitary suns float through intergalactic space like tiny lanterns wandering in the deepest night. They are few compared to the billions held safely inside galaxies, but they are still there, silent, unstirred, shining alone. Alongside those solitary wanderers drift clouds of gas, mostly hydrogen, spread so thinly across the void that even the densest pockets are still emptier than the cleanest vacuum we can create on Earth. Yet spread over millions of light years, that ghostly gas becomes a quiet presence, filling the darkness with a whisper of matter. In fact, astronomers believe a significant portion of the universe's ordinary atoms live out here in the wilderness between galaxies rather than inside the galaxies themselves. And woven through this emptiness is radiation, the ancient afterglow of the Big Bang, known as the cosmic microwave background. No matter where you drift in intergalactic space, this soft relic surrounds you, a faint echo of the universe's first light, warming the darkness with an almost imperceptible glow. Beneath all of it lies the invisible architecture of dark matter, forming halos around galaxies and delicate filaments that thread through the void like unseen scaffolding holding the cosmic web together. So while the stretches between galaxies look like perfect nothingness, they are actually laced with subtle structure, thin gas lone stars, ancient radiation, and the gravitational fingerprints of dark matter. To sense just how empty this space truly is, imagine shrinking the Milky Way to the size of a dinner plate. At that scale, Andromeda would be another plate resting about 4 meters away. Each plate would hold hundreds of billions of tiny grains of light, but the space between them, 4 meters of bare floor, would contain almost nothing at all. That image captures the reality of cosmic geography. Galaxies are luminous islands adrift in a deep ocean whose waters are nearly empty. When astronomers first discovered that the Milky Way was not the entire universe, but merely one among countless galaxies, this was the part that astonished them most. Not just the number of galaxies, but the sheer vastness separating them. The distances between these islands are so enormous that even though the universe contains billions of galaxies, they rarely collide by chance. Within a galaxy, stars are spaced light years apart, far yet still close enough that gravity binds them into organized structures. But between galaxies, the gulf grows so wide that for most of cosmic history, galaxies drift quietly evolving in solitude. Only over billions of years does gravity slowly draw some of them together. And when they finally meet, their stars sweep through one another like sparks scattered through wind, spectacular but rare. Most of the time, these immense gaps simply give galaxies room to grow, room to change, room to breathe in the cosmic dark. Even the intergalactic medium, the thin gas that lies between galaxies, is alive with quiet processes. It is warmed by quasars, those brilliant far-off galaxies whose central black holes unleash torrents of energy. It is enriched by supernova explosions, which fling metals and heavy elements into the void. And as galaxies move through this medium, they leave subtle wakes behind them, stirring the thin gas like ships gliding across a calm sea. In the last few decades, astronomers have turned to X ray and ultraviolet observatories to probe this intergalactic wilderness, capturing the faint shimmer of gas drifting through the spaces between galaxies. Those delicate signals reveal that the universe is far from empty. Even its quietest regions form a kind of cosmic environment, subtle structured and alive with matter, waiting to be drawn into new systems. These tenuous reservoirs of gas will one day seed fresh generations of galaxies, slowly gathering along filaments or falling inward under gravity's patient pull. And as we move outward beyond the familiar territory of the local group, the distances swell to an even more astonishing scale. Between our modest cluster of galaxies and the Great Virgo cluster lies a gulf of roughly 60 million light years, 60 million years of travel, even for light itself. This chasm makes the space between the Milky Way and Andromeda feel intimate by comparison. The regions separating galaxy clusters are among the most barren expanses in existence, containing little more than the occasional lonely galaxy drifting through the darkness like an isolated traveler crossing a desert. These vast voids dwarf everything we normally imagine when we think of space. When astronomers chart the large scale structure of the cosmos, they discover that emptiness is not a rare occurrence, it is the dominant feature. Most of the universe consists of tremendous cavities, with galaxies arranged along thin filaments and broad walls that outline those voids. The structure resembles a cosmic foam, bright edges tracing the boundaries of immense darkness. In this pattern, the voids are not background noise. They are the architecture upon which everything else is built. They give the universe contrast depth and shape the same way silence gives music its rhythm. These expanses of near nothingness aren't hostile, they're simply immense. They form the canvas on which galaxy clusters appear edges drawn in light against a field of shadow. Without the emptiness, the brilliance of galaxies would lose its meaning. The voids provide the stillness that allows the cosmic web to stand out, the quiet that lets energy and structure be seen. In a sense, the gaps between galaxies are as essential as the galaxies themselves, reminding us that the universe is not crowded, but spacious, not tightly packed, but spread out across unimaginable distances. Living inside the Milky Way, surrounded by billions of stars, it is difficult to truly feel how empty those intergalactic stretches are. Our night sky is rich with light. Our telescopes reveal countless galaxies. Our instruments pick up radiation everywhere. But if you were somehow placed far from any galaxy adrift in the deep between cluster void, the view would be starkly different. The sky would be nearly black. Only the faintest smudges of distant galaxies would punctuate the darkness scattered so thinly that the heavens would feel almost bare. No Milky Way band, no familiar constellations, just an ocean of quiet. And yet, even there, you would not be entirely alone. The soft murmur of the cosmic microwave background would still bathe you in ancient light. Thin clouds of intergalactic gas would still drift silently around you. Invisible strands of dark matter would still shape the space beneath your feet, even if you could not see them. The emptiness would never be absolute. It would be subtle, filled with the faintest traces of what once was and what will be again, like the lingering echo after a song has ended, still vibrating quietly in the air. When we reflect on the spaces between galaxies, something subtle changes in how we see our own. The Milky Way, which feels so full and bright when viewed from within, becomes a single glowing island set against a vast but quiet sea. Its brilliance stands out precisely because of the darkness that surrounds it. Its structure holds meaning only because there is space around it, room for separation, room for identity, room for motion. Without those gaps, galaxies would blur into one another, their shapes lost in constant interaction. But with them, the universe becomes a tapestry of islands and open waters, clusters of light, suspended in silence. The emptiness is not an error, it is the backdrop that allows the design to exist at all. Seen this way, the intergalactic gulf feels less like a threatening void and more like a reminder of proportion. Those distances tell us that the universe is spacious enough for countless galaxies to unfold without crowding. They allow the Milky Way to orbit to evolve to interact only on timescales measured in billions of years rather than constant collisions. They show us that the cosmos is sculpted not only by what is present, but by what is absent. The spaces in between are as important as the structures themselves, framing, shaping, and giving context to everything that is. And in a quiet way, this mirrors something true in our own lives. We often pay attention to what fills our days, the tasks, the events, the responsibilities. But the pauses, the stillness, the intervals between experiences give shape to the whole. Without spaces, meaning dissolves. In the universe, too, the silence is not emptiness, it is architecture. So the gap between galaxies, so enormous, so seemingly bare, is not a void at all. It contains thin veils of gas, wandering stars, ancient radiation, and the gravitational presence of dark matter. It is threaded with filaments and shaped by invisible hands. It is a stage, a medium, a sea across which galaxies drift. It may appear empty, but it holds the cosmic web together in a quiet, essential embrace. And from that stillness, we can push outward once more. When we zoom back another step, something striking begins to appear. The galaxies do not float through space like solitary ships on a random sea. They gather, they form families and communities drawn together by gravity's long reach. They shape larger structures, clusters and superclusters that weave the universe into patterns far grander than any single galaxy. A galaxy cluster is exactly what its name suggests, not a loose association like the local group, but a deep gravitational well containing dozens, hundreds, sometimes thousands of galaxies. These systems orbit a shared center of mass, immersed in a vast reservoir of scorching gas, and wrapped in a massive halo of dark matter. In clusters, galaxies move like fish in a shared ocean, their motions intertwined, their histories braided over cosmic eras. One of the nearest major clusters, and one of the most studied, is the Virgo cluster, sitting roughly 65 million light years from where we are. Inside this vast region are more than 1,000 galaxies, elegant spirals, reminiscent of the Milky Way, gigantic ellipticals holding trillions of stars, and countless small dwarfs sprinkled throughout like faint embers. If you had a telescope powerful enough to take in the entire scene at once, the view would be astonishing. The sky would appear crowded with galaxies, each glowing like a distant jewel suspended in the dark. But clusters are far more than gatherings of galaxies. They are filled with an enormous reservoir of superheated gas reaching temperatures of tens of millions of degrees, so hot that it shines not in visible light, but in X rays. This intracluster medium actually outweighs the galaxies themselves, reminding us once again that the universe is built from layers we cannot see with our eyes alone. The galaxies drift through this blazing ocean like silent travelers, their stars gliding unaffected while their gas is tugged, compressed, or stripped away by their passage. And dominating everything is dark matter, whose gravity forms the deep, invisible well that holds the entire cluster together. In that sense, a cluster is less a collection of separate objects and more a single interconnected ecosystem galaxies, gas, and dark matter entwined in a complex gravitational dance. Clusters do not exist in isolation. They weave themselves into even larger formations called superclusters. These are sprawling regions where many clusters and galaxy groups are linked across hundreds of millions of light years. The Virgo cluster, enormous as it is only one node within the Virgo supercluster, a broad, gently curved structure in which our own local group occupies a quiet outer edge. For many years, astronomers described our cosmic address this way: the Milky Way within the local group on the outskirts of Virgo. But as our maps grew more sophisticated and the cosmic web became clearer, it turned out that even the Virgo supercluster was only a small part of something more immense. In 2014, researchers charting the flow of galaxies through space proposed an even larger structure, Laniakea, a Hawaiian word meaning immense heaven. Laniakea spans nearly 500 million light years and gathers together numerous clusters, including Virgo and many of its neighbors, into a single gravitational continent of the cosmos. Roughly 100,000 galaxies are part of this vast region, all drifting together through space, following the subtle pull of gravity toward shared attractors like rivers flowing through a distant valley. Our local group sits on one of Laniakea's outer streams, drifting slowly along gravitational currents toward its central basin, a region astronomers call the Great Attractor, a dense congregation of galaxies and unseen matter that tugs everything in its direction. This insight shifted our cosmic perspective yet again. We are not just residents of the Milky Way, not merely members of the local group, not only neighbors to Virgo. We are part of Laniakea, a supercluster so vast that even the word immense barely hints at its true scale. What makes this picture come alive is the idea of gravitational flow. Galaxies are not stationary ornaments scattered in space. They move slowly, steadily, along pathways carved by mass, the way streams follow the slope of a valley. These pathways form what astronomers sometimes describe as cosmic highways, invisible lanes sculpted by the distribution of dark matter, outlined faintly by thin gas, and traveled by galaxies over billions of years. These are not roads in the human sense, yet they serve a similar purpose. They connect regions, guide motion, and shape the grand structure of the universe. When scientists trace these flows, the universe transforms from a random sprinkling of points into a connected architecture, a web where each filament leads to a junction, each junction to another, all woven together across distances so great they defy ordinary language. To grasp the magnitude, imagine the Milky Way shrunk to a grain of sand. On that scale, the local group becomes a small pebble, the Virgo cluster a hefty stone, and Laniakea spreads out like a continent. Then imagine that continent drifting in an ocean filled with countless others, each one a supercluster with its own rivers of galaxies flowing inward along ancient gravitational channels. Seen this way, the universe stops resembling a sparse void dotted with islands of light. Instead, it reveals itself as a vast network, a cosmic web, where glowing filaments connect luminous nodes, while huge cavernous voids stretch between them like giant bubbles in a foam. Clusters, superclusters, and these cosmic highways are the underlying framework of the web, the scaffolding that holds the galaxies in place. The presence of these enormous structures would have been unimaginable less than a century ago. In the mid 20th century, astronomers still pictured galaxies as mostly independent, with clusters being rare, isolated pockets of association. It wasn't until large surveys began charting the redshifts of thousands of galaxies that the bigger picture emerged. The first full maps revealed immense filaments and sweeping walls, structures so vast they seemed to rewrite the rules for how matter could arrange itself. The Sloan Great Wall, discovered in 2003, stretches more than a billion light years. The Hercules Corona Borealis Great Wall, identified a decade later, is even larger, one of the mightiest structures known in the entire observable universe. These discoveries made it clear that clusters and superclusters are not the top of the hierarchy. They are pieces of an even broader cosmic lattice woven into the fabric of the web itself. And yet, despite their gargantuan scales, these structures are surprisingly fragile. The filaments are slender, the clusters within them are spread apart, and the voids that surround them are unimaginably vast. Most of the universe remains empty, but the parts that contain matter reveal a pattern that repeats across levels. Galaxies gather into groups, groups into clusters, clusters into superclusters, superclusters into filaments, and filaments into enormous walls spanning hundreds of millions of light years. This hierarchy stretches upward as far as our instruments allow us to see, but it does not continue indefinitely. When we zoom out beyond a few billion light years, the intricate filaments of the cosmic web begin to dissolve into uniformity. On those colossal scales, the universe smooths out. The grand walls and superclusters become subtle ripples on the surface of something even vaster and more evenly spread. From our vantage point inside the Milky Way, these immense structures are almost impossible to sense directly. Our night sky reveals only the nearest stars. Even with telescopes, we see galaxies as isolated smudges of light. The threads that link them, the filaments flows, and highways are too wide, too faint, too expansive to witness with human eyes. Only through immense sky surveys, all sky maps, and simulations built from billions of data points does the cosmic web reveal itself. Yet once you know it exists, the universe changes character. The stars above your head stop being lonely sparks. They become part of a spiral system. That spiral belongs to a group. That group is tied to a cluster. That cluster is woven into a supercluster. And all of these structures ride on invisible rivers of gravity, slowly migrating through space over billions of years. This understanding reshapes our sense of motion. On Earth, when you walk down a road, you trust that it leads somewhere. When you drive a highway, you feel the connection between cities. In the same way, galaxies drift along cosmic highways, not wandering at random, but following routes carved by mass. Our local group is gently sliding toward the Virgo cluster. Virgo itself is being drawn inward within Laniakea, and Laniakea is linked to neighboring superclusters in ways that play out over incomprehensibly long spans of time. These flows sculpt the future of the cosmos, guiding mergers, orchestrating encounters, and shaping the evolution of structures yet to form. To see the universe through this lens is to see it alive with motion, with gravity, with pathways that connect the very largest of structures. And it is worth pausing to understand what it means to belong to something as colossal as Laniakea. The name Immense Heaven is perfectly chosen, 500 million light years from end to end, around 100,000 galaxies, filaments that stretch like intergalactic rivers, clusters that act like luminous cities, groups that resemble small towns, all interconnected, all flowing, all forming one vast gravitational domain. And we on a tiny planet orbiting an unremarkable star tucked into a minor spiral arm are fully part of that, not outside it, not looking in from afar, but inside it, moving with it, carried along by the same cosmic currents as every other galaxy in our region of space. The scale may feel overwhelming, but the connection is profoundly intimate. Laniakea is not something distant. It is our home on the largest map the universe offers. When you linger on the image of clusters, superclusters, and the cosmic highways threading between them, the universe begins to look like a grand landscape. These are the continents and coastlines of the cosmos. They are the roadways along which galaxies travel and the luminous cities where they gather. They reveal that the universe is not a chaotic spray of matter, but a structured pattern, delicate, enormous, and interconnected. And even these colossal structures, these giants that stretch across hundreds of millions of light years, remain just as pieces of something larger still. The deeper we look, the more the universe reminds us every structure, no matter how vast, is part of another structure beyond it. When we gaze out at clusters, superclusters, and filaments spanning hundreds of millions of light years, it's natural to be swept up by sheer scale. But almost immediately, another quieter question arises beneath the wonder. How do we actually know how big these things are? How can anyone say with confidence that the Milky Way is about 100,000 light years across that? Andromeda sits roughly 5 million light years away, or that the Virgo cluster stretches over tens of millions. No spacecraft will ever make that journey. No physical ruler can be laid down across such distances. They lie completely outside ordinary human experience, and yet astronomers have managed to turn them into numbers we can write, compare, and use. The way they do this is both ingenious and beautifully simple once you see the logic. At the heart of it all is light. Every star, every galaxy, every cluster radiates energy outward, and that light carries a record of its origin. It spreads through space, growing fainter with distance, but encoded in its color, brightness, and spectrum is the information about where it came from, how it is moving, and what it is made of. Astronomers treat that light as a messenger. They do not touch distant objects directly. Instead, they listen to what their light is quietly telling them. But turning that message into a distance is not straightforward. There is no single switch that reveals a how far. Instead, astronomers use a layered approach known as the cosmic distance ladder, a series of techniques, each valid, over a certain range, each one calibrated using the step below so that together they reach from the nearby stars all the way out to the largest structures we can see. The first rung of that ladder is parallax, a simple geometric effect you can feel in your own body. Hold a finger in front of your face and look at it with your left eye, then your right. Against the distant background, your finger seems to jump. That apparent shift comes from viewing the same object from two slightly different positions. Astronomers use Earth's orbit to do the same thing on a cosmic scale. They observe a nearby star at one time of year, then again 6 months later when Earth has moved to the opposite side of the Sun. Relative to the far off background of more distant stars and galaxies, the nearby star appears to shift by a tiny angle. The closer the star, the larger that shift. With simple trigonometry, that angle translates into a distance. Parallax is wonderfully direct. It relies only on geometry and careful measurement. But its reach is limited. Beyond a few thousand light years, the angular shift becomes so small that even our best instruments struggle to detect it. With spacecraft like Gaia, however, astronomers have pushed parallax farther than ever before, measuring this tiny wobble for more than 1 billion stars and building a precise three-dimensional map of the Milky Way. Once parallax has given a solid foundation for the nearest stars, the next rung of the ladder comes into play standard candles. These are objects whose true power, their intrinsic brightness, is known from physics or careful calibration. If you know how bright something really is, and you see how bright it appears from Earth, you can infer as to how far away it must be. The farther it is, the dimmer it will look in a predictable way. Among the most important standard candles are stars called Cepheid variables. These stars rhythmically brighten and dim, pulsing in a steady cycle. Crucially, the length of that cycle is linked to their true luminosity. The longer the period of the pulse, the more luminous the star. By measuring how quickly a Cepheid brightens and fades, astronomers can infer its intrinsic brightness, compare it to how faint it appears in the sky, and from that simple ratio extract its distance. In this way, a flickering star becomes a ruler, stretching far beyond the reach of parallax, carrying our cosmic measurements outward one heartbeat of light at a time. By studying the rhythm of a Cepheid's pulse, astronomers learn its true power, and once they know how bright the star actually is, they can compare that intrinsic brightness to the faintness seen from Earth and calculate the distance between us. These stars extend our reach far beyond what parallax alone could ever allow, pushing our measurements outward into nearby galaxies and giving us our first reliable foothold outside the Milky Way. Another powerful type of standard candle comes from type Ia supernovae explosions of compact white dwarf stars that consistently reach the same peak brilliance. Because they shine with extraordinary intensity, visible across billions of light years, they become essential markers on the largest scales. By studying how their light rises and fades and matching those curves to the known standard, astronomers can place galaxies on the cosmic map with impressive accuracy. The study of these supernovae in the late 1990s even revealed one of the most surprising findings in modern cosmology. The expansion of the universe is accelerating. That discovery introduced the idea of dark energy, showing that the methods we use to measure distance don't just reveal where things are, but also how the universe itself changes over time. Spectroscopy adds another key tool. When light travels across space, it carries the signatures of the atoms that emitted or absorbed it, tiny patterns that appear in its spectrum like codes waiting to be read. But this same spectrum also reveals something deeper, the redshift. As the universe expands, the light from distant galaxies is stretched to longer, redder wavelengths. The more stretched the light, the farther away the galaxy. This relationship, identified by Edwin Hubble, has become one of the central ways we map the structure of the universe. By calibrating redshift against other methods, astronomers can trace galaxies billions of light years distant. It's not perfectly clean. Local gravitational motions can blur the measurements. But on the grand scale, redshift reveals the shape of the cosmic web. Gravity itself becomes another form of measurement through gravitational lensing. When light from a distant galaxy passes near a massive object like a cluster, its path bends, producing arcs, stretched images, or even multiple copies of the same background object. By analyzing these distortions, astronomers determine the mass of the lensing object and estimate the distance to the background source. This method also exposes the hidden presence of dark matter, the invisible scaffolding of the universe, because the bending of light reveals mass we cannot see directly. Measurement in this sense becomes a way of exposing what would otherwise remain hidden. Time, too, can act as a ruler. Pulsars, the fast spinning remnants of massive stars, send out beams of radiation with incredible regularity. By watching tiny variations in those pulses, astronomers detect motions and distances with remarkable precision. Even quasars, the brilliant, energetic hearts of distant galaxies, vary in brightness in ways that can be used as experimental distance tools. These techniques are more exploratory, but they show how far astronomers will stretch their creativity to measure the immeasurable. The cosmic distance ladder earns its name because each method rests on the one before it. Parallax anchors our measurements. Cepheids extend the reach. Supernovae push the ladder deeper into space. Redshift expands it to the edges of the observable universe. Each layer reinforces the next, forming a chain of understanding that carries us from the nearest stars to the farthest galaxies. And while no method is perfect, uncertainties accumulate and debates continue over exact values, the latter remains one of the most extraordinary achievements in astronomy. It transforms distances too vast for human intuition into something we can describe, compare, and study. It turns the unreachable into something we can almost touch with our minds. But even with every limitation, the broader view remains steady enough that we can draw maps of the cosmos, trace its outlines, and speak with confidence about the size of the Milky Way, the distance to Andromeda, and the scale of the universe itself. It is worth pausing to recognize how astonishing that achievement truly is. From a small world circling an ordinary star, our species has learned to measure distances so immense that the light carrying those answers has been traveling longer than human history, longer than life as we know it. We have developed instruments sensitive enough to detect angles as tiny as a hair seen from across a city. We have identified stars whose steady brilliance can serve as cosmic markers, explosions that illuminate the darkness across billions of years, and spectral shifts that reveal the stretching of space itself. Measuring what once seemed immeasurable requires a blend of imagination, patience, and precision, and yet we have done it slowly, building a map of the universe that both humbles us and expands our sense of what is possible. This knowledge subtly reshapes how we experience the night sky. To say that Andromeda lies more than 2 million light years away is not simply to recite a number. It is to understand that the faint blur above the horizon is a galaxy whose light departed long before humans existed. To say that the Virgo cluster lies 65 million light years away is to realize that the photons reaching us tonight began their journey when dinosaurs still walked the earth. And to say that the cosmic microwave background comes from more than 13 billion years ago is to acknowledge that the oldest glow in the sky is the cooling echo of the universe's birth. Distance becomes time, and time becomes a bridge. Measurement transforms ancient light into a living timeline, connecting our small present moment to events far beyond our planet and far before our species arrived. The numbers stop being simple quantities. They become coordinates in a cosmic story, markers that show where we stand in a history larger than anything we can live to witness. At the same time, every measurement carries uncertainty. The universe is enormous, and our tools, though extraordinary, are still imperfect. Distances are refined as telescopes improve, as surveys widen, as new techniques allow for better calibration. Values shift slightly, maps sharpen. The picture becomes clearer, but the essential truth remains unchanged. Galaxies are immense. The universe is larger still, and our place within it is both tiny and remarkably privileged. The work of measurement is never finished. It is a continuous effort to bring the unreachable a little closer, to illuminate what will always in some way remain beyond full grasp. And as that idea settles, the phrase measuring the immeasurable stops feeling contradictory. The universe may lie far beyond human scale, but it does not lie beyond human curiosity. It invites us to reach to question, to decode the faint messages carried by ancient light. It reminds us that while we may be small, our capacity to understand is vast, and that is its own kind of wonder. We cannot step outside the cosmos and lay a ruler across galaxies, yet we can measure with subtler tools light motion, gravity, and time. With those tools, we climb the cosmic distance ladder, one careful rung at a time, reaching farther with each new method until we arrive at the limits of what light can deliver to us. And although horizons will always remain regions, forever hidden because their light has not yet reached our world, the act of reaching for them brings the universe into focus piece by piece. From the tiny shift of a nearby star to the stretched wavelengths of galaxies billions of light years away, we have transformed what seems immeasurable into something we can describe, compare, and place within a coherent structure. In doing so, we've gained not just numbers, but a sense of relationship, how the Milky Way fits into the larger fabric, how the universe extends far beyond it, and how all of it is connected by laws that remain steady across unimaginable scales. When you consider how astronomers measure the cosmos, you begin to see not a set of formulas, but a quiet partnership between human curiosity and the universe itself. Parallax Cepheids supernovae, redshifts, each method is a rung on a ladder built over centuries. We climb those rungs not to escape our place, but to understand it more clearly. And when we finally reach the uppermost rung available to us, we find ourselves looking out toward the broadest horizon we can ever hope to see, the observable universe. The phrase is deliberate. It is not simply the universe. It is the part we can witness, the region where light has had enough time to arrive. It implies vastness, yes, but also a boundary, one shaped not by walls, but by time itself. The observable universe is defined not only by its distance, but by the age of its light. Because light travels at a finite speed, swift beyond comprehension at nearly 300,000 kilometers per second, yet not infinite, every outward glance becomes a journey backward in time. The moon shows its face as it was a moment ago. The sun shows us its past from 8 minutes earlier. Andromeda reveals itself as it existed 2 million years before humans walked the earth. Look deeper, and time stretches further. At the outer limit, the oldest light we can observe comes to us as the cosmic microwave background, the faint glow released when the universe cooled enough for light to travel freely about 380,000 years after the Big Bang. Beyond that moment, the early cosmos was too dense and energetic for photons to move. No light older than that exists for us to see, so the horizon of observation begins there. This boundary is not a physical edge. It is a horizon shaped by the finite age of the universe and the finite speed of light. And because space has been expanding throughout those 38 billion years, the most distant regions we can observe are now far farther away than their light travel time suggests. Those regions have been carried outward by cosmic expansion and now sit roughly 46 billion light years from us. That means the observable universe spans about 93 billion light years from one side to the other, a diameter so enormous that it barely fits into imagination even when spoken slowly. Inside this observable bubble lies a wealth of structure. Current estimates suggest roughly 2 trillion galaxies fill this sphere, each galaxy containing hundreds of billions of stars. Altogether, that's on the order of 10 to the 24th power stars, a 1 followed by 24 zeros, a number that defies the tongue and overwhelms the mind. If each star were a grain of sand, they would not merely fill every beach on Earth, they would do so repeatedly. And even that staggering total may be an underestimate because many faint galaxies slip beneath the limits of our current telescopes. The observable universe isn't simply vast. It is saturated with light from ancient stars, light from distant galaxies, light from cosmic events that unfolded long before Earth was formed. Yet we never see it all at once. No single telescope can contain an entire universe in its field of view. Instead, astronomers assemble the cosmic picture, slowly mapping one patch of sky at a time and weaving the pieces into a panoramic tapestry. The Hubble Ultra Deep Field is one of the most iconic examples. When astronomers aimed the Hubble Space Telescope at a tiny, almost forgettable patch of sky no larger than a grain of sand held at arm's length, they let the telescope drink in light for many days. What emerged from that patient gaze was astonishing, a portrait containing thousands of galaxies, each one a little whirl smear or sparkle of ancient light. And if a single grain sized window contains that many galaxies, imagine multiplying that view across the entire sky. You arrive not at thousands or millions, but billions of galaxies. The James Webb Space Telescope has pushed this insight even further, reaching deeper into cosmic time revealing galaxies that formed less than a billion years after the Big Bang. These glimpses are like looking through a keyhole only to discover an entire city stretching far beyond the horizon, rich, sprawling, and endlessly layered. The observable universe is anything but random. Its structure follows the same cosmic web we explored earlier. Galaxies assemble into long strands. Those strands twist into walls, and between them, enormous voids open like dark valleys, some stretching hundreds of millions of light years across, with barely a handful of galaxies inside. Meanwhile, the densest regions shone brilliantly clusters, where galaxies are packed so tightly that their combined light forms a soft glow. When astronomers map these structures, they reveal a pattern that looks strangely biological, like neurons branching through a brain or filaments woven through living tissue. It is a cosmic reminder that order emerges on every scale when gravity patiently sculpts matter over billions of years. One of the most humbling truths about the observable universe is that it is not the universe. It is simply the portion from which light has had time and to reach us. Beyond our horizon, the cosmos almost certainly continues. There is no boundary at 46 billion light years where space suddenly stops. Instead, the universe likely stretches much farther, perhaps unimaginably farther, maybe even without end. But we cannot witness that region because its light has not yet arrived. The observable universe is a bubble defined not by physical walls, but by time, by the speed of light, and by the expansion of space itself. To see its edge is to encounter the limit of our vision, not the limit of existence. This boundary is what makes the cosmos feel even more mysterious. Everything we know, every galaxy, every cluster, every filament is inside our bubble of light. Beyond it lies a region we cannot observe, but can still consider with wonder. Perhaps the same patterns continue outward. Perhaps the structures change or become richer or stranger. Perhaps other regions of the cosmos operate under conditions unfamiliar to us. Or perhaps the universe repeats itself endlessly in every direction. We cannot say. The observable universe is defined as much by what it includes as by what it hides. What makes this even more remarkable is how recently humanity learned any of it. Barely a century ago, astronomers were still debating whether the Milky Way contained all the stars in existence, or whether those faint smudges in the night sky were separate galaxies of their own. In the span of just a few generations, our cosmic picture has expanded from a single galaxy to trillions in evolution of understanding as vast as the universe it describes. The observable universe, the version we describe today, would have been unimaginable to earlier generations. And yet, within the span of barely a century, our understanding has widened from believing the Milky Way was the entire cosmos to realizing it is merely one galaxy among trillions suspended inside a sphere of visibility roughly 93 billion light years across. This shift in awareness is one of the most profound transformations in human thought. It alters not only our scientific models, but also the quiet internal sense of where we fit in the unfolding story of existence. To look out toward the limit of what we can observe is to recognize our smallness, yes, but also to recognize our astonishing ability to comprehend what lies far beyond us. From Earth, the observable universe appears centered on us simply because we can look outward in every direction. But the same is true for any observer anywhere. A being in a galaxy billions of light years away would also see a sphere about 93 billion light years wide, but filled with different galaxies than the ones we see. This alone shows that the observable universe is not a boundary of the cosmos, but a personal horizon shaped by where you stand and by how far light has traveled. It is like standing in a thick fog. Each person sees a circle centered on themselves, but the fog stretches beyond everyone's view. Our horizon surrounds us, but it does not mark the edge of all that exists. Realizing this brings not only wonder, but a quiet kind of reassurance. The observable universe contains everything we can ever detect, every star whose light reaches us, every galaxy, bright or faint, every ripple of cosmic radiation drifting through space. It is a complete picture from our perspective, even though it is not the full picture of reality. To exist within it is to live inside a slowly expanding sphere of knowledge, because with every passing moment, light from slightly farther away manages to arrive. The observable universe grows not by expanding into anything, but by revealing more of itself as time unfolds. More of the past is continually falling into view. More of the cosmic story reaches us every second. Seen this way, the observable universe is less a fixed container and more a moving frontier. It changes, it widens, it deepens with time. It reminds us that we inhabit a living cosmos, not a static one, a universe where the possibility of discovery never stops. The horizon you glimpse today is one version of the truth. 1,000,000 years from now, that horizon will be larger, filled with galaxies that are currently invisible, expanding our map and altering our sense of scale. The boundary of the observable universe isn't a wall, it's a shifting line where the oldest light meets the limit of our sight. So, when we talk about seeing the observable universe, what we are truly describing is our ability to detect the oldest, faintest messages ever sent. We see galaxies whose light left when the universe was young. We see the cosmic microwave background, the faint thermal echo from when the cosmos first became transparent. We see matter arranged on the grandest scales, threads and sheets stretching across unimaginable distances. We see a bubble of space, roughly 93 billion light years across, glowing with the light of 2 trillion galaxies. And beyond that softly lit boundary, we imagine still more. The glimpse is not total, but it is enough. Enough to feel the immensity, enough to understand that our home galaxy is small compared to the whole, enough to recognize that we live within a universe far beyond the reach of language. The observable universe is not the final answer. It is simply the farthest horizon our current physics allows us to see. To witness it is to stand at the frontier of knowledge, facing a vastness that is both knowable and mysterious, finite in what we can observe, but almost certainly unbounded in reality. When we hold the image of the observable universe in mind, with its shimmering horizon stretched across some 93 billion light years and its population measured in trillions of galaxies, the next question arises almost automatically. How does our own Milky Way fit into that vast expanse? We recognize that our galaxy is enormous by any human standard, roughly 100,000 light years wide, home to hundreds of billions of stars shaped as a barred spiral with sweeping arms and a luminous central bulge anchored by a supermassive black hole. We know it contains rivers of dark matter, drifting dust, sculpted gas, ancient clusters, and long tidal streams pulled from past mergers. And yet, when we set the Milky Way against the backdrop of the entire observable universe, it becomes clear that our galaxy is not a titan at all. It is an ordinary spiral among uncountable others, a single pattern woven into a tapestry so large that the mind can only approach it slowly. Comparing the Milky Way to the universe is like comparing one grain to a desert dune, one cresting wave to the entire ocean. And yet, making that comparison with care helps reveal the scale of both and shows how our home fits into the greater whole. The first way to compare them is by raw size. The Milky Way spans about 100,000 light years from one side of its disk to the other. The observable universe spans about 93 billion light years. Placing those numbers side by side, you can see the proportion 100,000 versus 93,000,000,000. The result is staggering. The observable universe is roughly 900,000 times wider than the Milky Way. And when you consider volume rather than diameter, the difference becomes almost unimaginable. Cube that ratio, and the observable universe becomes about 1018 times larger in volume, a billion times greater. If you shrank the Milky Way to the size of a small coin, the observable universe would be an entire continent. If you imagined the Milky Way as a single bead of water, the observable universe would be an ocean stretching far beyond the horizon. The next way to compare is by population. The Milky Way holds somewhere between 200 and 400 billion stars. That figure alone is breathtaking. So many suns that every human alive could be assigned dozens of stars each. But the observable universe contains roughly 2 trillion galaxies. If we assume each galaxy holds around 100 billion stars on average, then the total number of stars becomes roughly 1024 a septillion, a 1 followed by 24 zeros. Against that backdrop, the Milky Way's stars form only a tiny portion of the total hundreds of billions out of a septillion. To picture it more simply, imagine every star in the Milky Way as a single grain of rice, a quantity that could fill a tall storage silo. Now imagine that every star in the observable universe as grains of rice, they would fill all the Earth's oceans many times over. The numbers escalate until they dissolve into abstraction, and yet they remain precise enough to offer perspective. They anchor our imagination, giving shape to the difference between our galactic home and the vast cosmic sphere that surrounds it. The Milky Way is not remarkable in its design. It is a barred spiral of moderate size, with a fairly typical supermassive black hole resting at its center. Across the cosmos, galaxies appear in every imaginable form, huge ellipticals containing trillions of suns, tiny irregular dwarfs holding only a few million graceful spirals with sweeping arms and smooth lenticular shapes that sit somewhere in between. Our Milky Way occupies the middle ground of this diversity. Andromeda, the nearest major companion, is larger. Some giant ellipticals, like M87 in the Virgo cluster, dwarf both of them with star counts in the trillions. Meanwhile, modest galaxies like the Magellanic Clouds are significantly smaller. In the grand catalog of cosmic structures, the Milky Way is neither exceptional nor extreme. To us, it feels vast and irreplaceable, but on a universal scale, it is an ordinary spiral in a universe filled with spirals. That ordinariness is meaningful. If our galaxy were an anomaly, it might imply that our cosmic neighborhood is rare. But its typical nature suggests something far more intriguing, that galaxies similar to ours may be scattered throughout the universe, each with its own stars, its own planets, its own possibilities for life. It hints that whatever unfolds here may echo elsewhere. To compare the Milky Way with the universe is not to reduce its importance, but to recognize it as one thread in a much larger design. To ground this sense of scale, astronomers often use analogy. If the Milky Way were reduced to the size of a single city, the observable universe would be larger than the entire Earth. If the Milky Way were the size of a single house, the universe would be an entire world. If the Milky Way were a grain of sand, the observable universe would be a shoreline stretching for thousands of kilometers. Each comparison helps, yet none truly captures the enormity, because the human mind evolved to navigate forests and mountains, not distances measured in billions of light years. We can only approximate gesture toward the difference and let the feeling of scale wash over us. Even a faint hint is enough to sense how small our galaxy is and how immense the universe surrounding it must be. The comparison also brings time into sharper focus. The Milky Way is roughly 13 billion years old, nearly as ancient as the universe itself. It emerged not long after the first galaxies formed, shaping itself through mergers, collisions, and the slow accumulation of gas. Many of its stars were born close to the dawn of cosmic history. In that sense, the Milky Way is ancient, but the universe stretches farther back still. The first galaxies ignited when the cosmos was only a few hundred million years old. From that beginning, galaxy after galaxy has formed, collided, restructured, and evolved. The Milky Way is simply one chapter in that much larger saga, a chapter among trillions, each unfolding its own story, each contributing to the cosmic narrative. Another meaningful comparison comes from motion. The Milky Way does not drift through space alone. It moves within the local group, slowly drawing closer to Andromeda. The local group itself is falling toward the Virgo cluster. Virgo is being pulled deeper into the giant Laniakea supercluster, and Laniakea is connected to neighboring superclusters through gravitational currents that run through the cosmic web like invisible rivers. All of this motion is part of a larger flow shaped by gravity and dark matter guiding the dance of galaxies over billions of years. Compared with these vast gravitational currents, the Milky Way is like a single leaf drifting along the surface of a great cosmic river carried gently yet irresistibly by forces far larger than itself. The observable universe becomes the entire river system, branching, flowing, and stretching across unimaginable distances. The comparison reveals more than a difference in size. It highlights a difference in context. Our galaxy is not an isolated island. It is a small component of a much grander flow shaped by it moving within it, inseparable from it. This realization can feel humbling, but there is a quiet comfort in it as well. To understand that our galaxy is ordinary one among trillions small compared to the universe is to recognize that we are part of something unimaginably vast. Our position is not central, not privileged, not unique, and yet that very ordinariness connects us to the whole. The Milky Way is not diminished by the immensity around it. It gains meaning from it, gains perspective from it. To exist inside the Milky Way is to exist inside the universe itself, not apart from it, but woven seamlessly into its fabric. It is also worth remembering that while the Milky Way is tiny beside the observable universe, it is still immense from the human point of view. 100,000 light years from side to side, hundreds of billions of stars, billions of worlds, a structure so large that even crossing a fraction of it would take longer than human history. Our entire species occupies a minuscule corner of one spiral arm, and yet from that tiny foothold, we can compare our home to the entire observable cosmos. That layering of scale is part of the wonder. We are small beside our galaxy. The galaxy is small beside the universe, and yet we can contemplate all three from within a human mind. The act of comparing them is itself astonishing, a leap of imagination spanning billions of light years. Comparing the Milky Way to the universe also invites deeper questions about what lies beyond what we can see. The observable universe is only the portion from which light has had time to reach us. Beyond that horizon, the universe may continue without end. If space stretches on infinitely, then the Milky Way is not one of trillions, but one of an uncountable multitude scattered across endless cosmic terrain. Against that backdrop, the contrast between 100,000 light years and 93 billion light years shrinks. Both become tiny measures against the possibility of infinity. This does not make our galaxy less meaningful. Instead, it makes it even more remarkable that we can know it at all, that we can describe its shape, its size, its contents, and place it within the cosmic architecture. As we rest with this thought, the comparison becomes less about raw numbers and more about perspective. The Milky Way is our home. The universe is the greater landscape in which that home resides. To compare the two is to recognize that home can be both small and magnificent, both ordinary and breathtaking, both a grain of sand and an entire galaxy. It is to understand that scale is relative, that significance does not depend on magnitude, and that belonging to a galaxy, to a universe, to a cosmic story, far older and larger than we are, is its own kind of meaning, everything we are. And in that gentle paradox lies much of the wonder. A galaxy spanning roughly 100,000 light years, holding hundreds of billions of stars, becomes our entire cosmic neighborhood. Meanwhile, the observable universe stretches 93 billion light years across, filled with trillions of galaxies, each carrying its own history and possibility. One is the home we inhabit. The other is the grand stage on which all cosmic stories unfold. Both are immense, both are real, both are woven together, and in comparing them, we begin to understand where we fit small in scale, yet deeply connected to the whole. As soon as we place the Milky Way beside the universe, one truth becomes especially clear. Galaxies themselves are the fundamental building blocks of cosmic structure. Every star we see in the night sky, every nebula, every cloud of light belongs to our single galaxy. And when we pull back far enough, we discover that the observable universe is dotted with trillions of these luminous systems. Each one stands apart like an island floating in a vast cosmic ocean. This is why astronomers often describe galaxies as cosmic islands. The image is simple, but it captures something essential. Galaxies are pockets of light surrounded by darkness, self contained realms where stars are born, evolve, and eventually fade. They are cradles of worlds, laboratories of complexity, and nurseries for whatever forms of life the universe may allow. Thinking of galaxies as islands transforms the universe into an unimaginable archipelago, billions of islands scattered across an endless sea. The idea of island universes is not new. In the early 20th century, long before we truly grasped the scale of the cosmos, astronomers were still debating the nature of the spiral nebulae. Were these swirling shapes small clouds within our own Milky Way, or were they entire systems, galaxies, far beyond our own boundaries? Some argued for one model, others for the opposite. The answer arrived through the work of Edwin Hubble in the 1920s. By carefully measuring the stars within the Andromeda Nebula, he demonstrated that it was far too distant and far too large to belong to the Milky Way. It wasn't a cloud inside our galaxy, it was another galaxy altogether. With that single realization, the scale of the universe expanded dramatically. Our galaxy stopped being the entire cosmos and became just one island among countless others. The cosmic ocean grew millions of times broader in our understanding, and the Milky Way became a member of a much larger family. What makes the island metaphor especially fitting is not just the separation between galaxies, but the self contained nature of each one. Every galaxy is bound together by its own gravity. Stars, gas, dust, and dark matter orbit a shared center, just as everything on an island belongs to the landmass that holds it. Around each galaxy lies enormous emptiness distances so vast that even light must travel millions of years to cross from one island to another. Within a galaxy, the stars are its inhabitants, sharing a home with a common gravitational anchor. And just as islands come in many forms, tiny, sprawling, rugged, or lush, so too do galaxies. Some are dwarfs with only a few million stars. Others are giants containing trillions of suns. Spirals like the Milky Way lie in the middle, graceful in their balance, with sweeping arms wrapped around a luminous center. The diversity is immense, each galaxy carrying its own character, its own history of collisions, births, and transformations. No two galaxies are truly the same, just as no two islands share identical coastlines. Some galaxies unfurl their spiral arms like elegant shorelines curving around a luminous bay. Others form smooth, rounded ellipses, cosmic landmasses, polished by age and countless interactions, shaped the way ancient islands are softened by tides and time. Still others are irregular and chaotic, more like fragmented archipelagos sculpted by violent encounters. Each galaxy carries its own personality, its own lineage, its own story, written in orbits in starlight, in the silent movements of gas and dark matter. To travel through the universe in imagination is to drift from one island to the next, crossing vast distances to arrive at entirely new landscapes of suns and worlds. Galaxies are not simply collections of stars, they are ecosystems. Within drifting clouds of gas, new stars ignite like fresh campfires on a long inhabited island. They shine for billions of years before their fuel fades. Some settle quietly into dense white dwarfs. Others end in titanic explosions, supernovae that scatter heavy elements, carbon for life, oxygen for breath, iron for blood, into the galactic sea. Those elements then become the raw materials for the next generation of stars and planets. In this way, every galaxy renews itself. It takes the ashes of old stars and turns them into the chemistry of future worlds, keeping the cosmic archipelago alive and evolving. Each galaxy is not just an island, but a living island, shifting, growing, transforming over cosmic time. And the ocean between galaxies, the vast intergalactic voids, only makes this island metaphor more vivid. Inside a galaxy, stars may be separated by light years, yet compared to the emptiness beyond, they feel close, almost clustered. Between the Milky Way and Andromeda, for instance, lie more than 2 million light years of mostly empty space, with only a handful of wandering stars drifting through the darkness. Against that backdrop of nearly perfect emptiness, the interior of a galaxy feels vibrant, almost crowded. The deeper the ocean, the brighter the islands appear. Thinking of galaxies as islands also reshapes our sense of belonging. Living on an island teaches you about edges. You can walk to the shore and see where land ends and water begins. You can sense that your world is finite, even as you imagine others across distant horizons. To live within a galaxy is similar. We know the stars around us, the spiral structure that cradles our solar system. We know the shape of our home, and we know too that far beyond its boundaries lie countless other galaxies, other islands, glowing softly across an ocean we will never cross. Their distant presence deepens our understanding of where we are. Even if we cannot reach them, we are shaped by knowing they exist. The Milky Way is not a solitary island floating alone in the dark. It is simply one member of a vast archipelago that spreads across the universe, each galaxy its own beacon of light in a sea of cosmic night. Seeing it this way brings a mixture of humility and comfort. Humility because it reminds us that our home is not the center of creation, just one island among trillions scattered across unfathomable distances. And comfort because it reveals that we are not isolated. We are part of a community so large that its scale transcends imagination. The ocean may be too wide to cross, but the islands still shine toward us, their faint glows reaching our eyes as subtle smudges on the night sky. These distant galaxies are reminders that our cosmic neighborhood is far larger than the stars we see with the naked eye. And like islands on Earth, galaxies are not anchored in place. They drift through the cosmic ocean, pulled along by gravity's invisible currents. Sometimes their paths intersect, and when they do, entire galaxies merge. Their stars rarely collide. There is simply too much space between them, but their shapes distort, their gas clouds compress, and new waves of star formation ignite. These encounters are the tectonic events of the universe, reshaping islands, birthing new structures, and erasing old boundaries. The Milky Way itself has grown through such mergers, absorbing smaller galaxies, and in the distant future, it will fuse with Andromeda to form a completely new structure. The archipelago is alive, shifting endlessly. Thinking of galaxies as islands also changes how we imagine exploration. On Earth, explorers sailed across oceans, charting unfamiliar coasts and drawing the first maps of distant lands. In the cosmos, we cannot physically voyage between galaxies, but we explore in another way through the light they send us. Telescopes become our vessels riding on waves of photons instead of water. The observations we gather become maps of this cosmic archipelago, revealing shapes, distances, histories, and motions. In this sense, every beam of light is a messenger crossing the intergalactic sea, carrying the story of an island we will never touch but can still come to understand. Each photograph of a distant galaxy is like catching sight of another island far across a silent cosmic sea, another luminous shore, another home, another possibility. When astronomers captured the Hubble ultra deep field, revealing thousands of galaxies inside a patch of sky no bigger than a grain of sand held at arm's length, it was as if we were suddenly standing at the edge of an endless archipelago. Every speck of light became an island, each one holding its own history, its own future, its own potential for stars, planets, and perhaps even life. Seeing galaxies this way reminds us that they are more than swirls of gas and starlight. They are containers of possibility places, where matter condenses into suns, where planets gather around those suns, where atmospheres form, and where, under the right conditions, life might emerge. If life has taken root elsewhere in the cosmos, it almost certainly began inside a galaxy, on a small world orbiting one star among billions. In that sense, galaxies are not just islands of light. They are islands of meaning. They are repositories of stories, waiting to unfold, each one holding the potential for civilizations as rich and complex as ours. But what makes the metaphor even more intriguing is the nature of the ocean between these islands. On Earth, an ocean system is water, tangible, familiar, something we can sail across. In the universe, the ocean is emptiness. The separation is not a physical barrier, but the sheer scale of distance. Light itself, the fastest messenger in existence, needs millions or even billions of years to bridge the gap between one island galaxy and another. That makes the distances feel deeper, lonelier, more unreachable, and yet, despite the gulf, the light does arrive. It crosses the void, travels the darkness, and reaches us as a faint glow. The loneliness is softened by connection. The silence is pierced by distant whispers of other worlds. So, when we talk about galaxies as cosmic islands, it is more than poetic language. It is an accurate reflection of the universe's architecture. Galaxies are gravitationally bound worlds of stars, gas dust, and dark matter separated by immense voids, diverse in structure, dynamic in motion, and woven into the cosmic web. They are the building blocks of the universe, homes for stars, nurseries for elements, and the only known cradles for life. They are islands in every meaningful sense, and the universe stretches around them like a boundless, dark ocean. To live within the Milky Way is to reside on one of these islands, to inhabit a single shining shore in a chain of trillions. Our view is local, our night sky limited, but our imagination can roam freely across the archipelago. And once we imagine it, the next question naturally arises. How many islands are there? If the Milky Way is one among countless others, can we ever truly estimate how many exist within the observable universe? The question has fascinated astronomers since the moment telescopes revealed faint smudges beyond our galaxy. And although modern instruments give us breathtaking estimates, the final answer remains open, expanding, evolving, shifting with every improvement in our tools. Counting galaxies directly is impossible. The observable universe is simply too vast, and most galaxies are far too faint, too distant, or too obscured for even our most powerful telescopes to detect. Instead, astronomers use a technique similar to estimating how many grains of sand cover a beach by examining a handful of shoreline. They study a small, carefully chosen patch of sky in extreme detail, count the galaxies within that tiny window, and then scale those results to the entire sky. One of the most iconic of these windows is the Hubble Deep Field, and later the Hubble Ultra Deep Field. By aiming the Hubble Space Telescope at a minuscule, seemingly empty patch of sky and allowing it to gather light patiently over many days, astronomers uncovered a breathtaking truth: that tiny speck, no bigger than the size of a grain of sand held at arm's length, was overflowing with galaxies, thousands of them. Spirals, ellipticals, dwarfs, all compressed into a single microscopic window on the cosmos. When that density is scaled across the entire sky, the implication is staggering. The universe is far more crowded with galaxies than anyone once dared imagine. Later campaigns like the Hubble Frontier Fields pushed this even deeper using gravitational lensing to reveal galaxies otherwise too faint to detect. And the James Webb Space Telescope has opened an even earlier chapter of the cosmos unveiling galaxies that formed only a few 100 million years after the Big Bang primitive compact, burning with the raw light of the infant universe. Using these deep samples, astronomers' estimates of the number of galaxies have shifted radically over time. Throughout most of the 20th century, the common belief was that the observable universe held perhaps a few 100 billion galaxies, a mind bending figure already. But in 2016, a detailed analysis of deep field imagery suggested a far greater abundance. The true number might approach 2 trillion, that is 1,000 times more than the galaxies formally cataloged at the time, most of them faint, tiny dwarfs that slip beneath the sensitivity limits of our current telescopes. And yet they are still galaxies, in the full sense gravitationally bound islands of stars, gas and dark matter orbiting together in harmony. This revelation that the observable universe may contain on the order of 2 trillion galaxies reshaped our understanding of the cosmic archipelago. And even this enormous figure might still be an underestimate. As instrumentation improves, as surveys expand to deeper wavelengths and wider fields, we may discover that the population of galaxies is even richer. Countless faint systems may lie hidden in the universe's dimmest reaches, their light too diffuse to trigger our detectors. Others may have merged or been disrupted long ago, leaving behind only streams of stars. Estimating the number of galaxies is like trying to count every tree in a forest while standing in a clearing. You can tally what's in view, infer an average density, and project that estimate outward across the landscape. But you know inevitably that many trees remain hidden, tucked behind hills, obscured by shadows, or simply too small for your eyes to catch. The forest is always larger than what any one survey can capture. Another subtle difficulty comes from the question of definition. What exactly qualifies as a galaxy? On one end of the spectrum stand the colossal ellipticals, home to trillions of stars and dominating the core regions of clusters. On the opposite end are faint dwarf systems, holding only a few million stars and clinging together by the gentlest touch of gravity. Where does the threshold lie? At what point does a cluster of stars graduate into a galaxy? Astronomers typically draw the line at gravitational binding. If the stars form a self contained stable system dominated by its own mass, it earns the title of galaxy. But even this definition has gray areas. Some dwarf galaxies are so faint, so diffuse, that they blur the distinction between galaxy and star cluster. Others orbit larger galaxies as satellites. Should they be counted separately or as extensions of their parent systems? The criteria shape the tally, and the tally shapes our understanding of the cosmos. To bring all of this to human intuition, imagine the observable universe as a vast city seen from an airplane window at night. Every galaxy is like a glowing street lamp. Some shine brightly, others flicker faintly, some cluster together, others stand alone down long empty avenues. If you tried to count every street lamp from that vantage point, you could not do it directly. You would study a few neighborhoods, estimate the density scale, the result, and accept that your number, however large, would still fall short. Some lamps are hidden behind buildings, some lie beyond the horizon, some are too dim to distinguish at all. And so it is with galaxies. Even our best counts are approximations, snapshots filtered through the limits of our tools. But each refinement reveals something deeper about the cosmic landscape, that the universe is richer, more populated, more intricate than any early astronomer could have imagined, an archipelago of unimaginable scale, filled with islands of starlight drifting through the darkness. Just as with stars, the tally of galaxies is never a final figure. That estimate of 2 trillion is simply our best current approximation, an evolving number shaped by the limits of our instruments and the depth of our surveys. Embedded within that estimate is an unspoken truth. The universe likely contains more galaxies than even our most ambitious telescopes can reveal. And beyond the horizon of what we can observe, space almost certainly continues. If the cosmos stretches indefinitely, then the true number of galaxies might not merely be enormous, but unbounded. Asking for a final count becomes like asking for the number of grains of sand on an infinite shore. The answer is no longer numerical, it's conceptual, more than we can ever hope to measure. The observable universe gives us a bubble, a sphere carved out by the speed of light, and the age of the cosmos inside which we can make estimates. But the full extent of reality may stretch far past that boundary, populated with galaxies whose light will never reach us. In that sense, the question shifts subtly. When we ask how many galaxies exist, what we're truly asking is how many lie within our reach, how many we can detect or infer from the faintest smudges of ancient light. Whether the number is hundreds of billions or several trillion, it already surpasses anything the human mind evolved to comfortably imagine. Yet the deeper significance isn't the numeric total, it's the scale that the number hints at. To learn that the universe houses trillions of galaxies is to recognize that the cosmos is not merely vast, it is exuberant, overflowing with islands of starlight. Each galaxy holds billions upon billions of suns. Each is a cradle for planets, a canvas for chemistry, a stage where life could arise. The number is more than a statistic, it is a measure of possibility. There is a quiet humility in realizing that our Milky Way, with all its grandeur, is just one among this multitude. When we look up at the night sky, we see only the stars of our own home. The rest of the galaxies are so distant that they appear only as faint, ghostly blurs, yet each of those tiny smudges is as enormous and complex as our own. And across the entire sky, those smudges multiply until they reach into the trillions. The universe is not a lonely desert dotted with occasional lights. It is a thriving archipelago, a cosmic cityscape spread across unimaginable distances. The gaps between galaxies may stretch for millions of light years, but the sheer quantity of galaxies ensures that the cosmos is richly populated with luminous worlds. In that abundance, there is something deeply comforting. It is also soothing to accept that we may never know the exact number. The uncertainty is part of the wonder, part of the spaciousness of the universe. We can measure, sample, and estimate. We can refine our tools and stretch our understanding, but the cosmos will always hold more than we can catalog, more than our equations can capture. To live inside such a universe is to accept that some horizons remain forever beyond reach, that not every question yields a final answer. That mystery is woven into the fabric of existence, and yet the glimpse we do have is enough, enough to kindle awe, enough to help us understand that the universe is richer, fuller, and more intricate than any list or number could express. So when we ask how many galaxies exist, the truest answer is simple: more than we can see, more than we can count, more than we can imagine. Hundreds of billions at the very least. Trillions based on our latest estimates. Perhaps an endless multitude beyond the limits of our vision. Each one a shining island, each one a world unto itself, each one a node in the vast cosmic web. The total may be vast beyond comprehension, but the meaning is clear. The universe is overflowing with galaxies, and we inhabit one of them. That knowledge alone is enough to place us gently within the immensity, reminding us of our smallness and our belonging all at once. When we reflect on the staggering number of galaxies scattered across the cosmic sea, these trillions of luminous islands drifting in the dark, another question arises almost automatically. How do we see any of them at all? And what defines the outer edge of our sight? The answer is both simple and profound. Everything we know about distant worlds, distant epochs, distant galaxies comes to us through a single messenger light. Light is the universe's courier. It carries information across distances so enormous that the mind can barely hold them. Every star radiates it. Every galaxy glows with it. Every supernova quasar and flicker of cosmic fire sends out a signature that travels through space for millions or billions of years. And when even the tiniest fraction of that ancient light reaches us, we can decode it, we can measure it, we can translate it into an image of a place we will never physically reach. But light also imposes limits. Because it moves at a finite speed, and because the universe has only existed for a finite time, there are boundaries beyond which nothing can be seen. The universe sets a horizon not as a wall, but as the edge of our light-born memory. To think about distance is to think about the miracle of sight and the natural constraints around that sight. It is to confront the horizon of what is visible. The first truth is one of perspective. Whenever you look upward, you are not seeing the present, you are seeing the past. The moon is 1 second old by the time its light reaches your eyes. The sun is 8 minutes old. The nearest stars shine from years in the past. Andromeda glows from 2.5 million years ago. The most distant galaxies captured by Hubble or James Webb shine from more than 13 billion years in the past light, from an era when the cosmos was newly formed. The night sky is not a map of distance, it is a map of time. We are wrapped in concentric shells of history. each shell representing light that began its journey at a different moment in the universe's life. The farther out we look, the younger the universe appears, as though we are peeling back layers of cosmic memory. This layering means something extraordinary. The deeper we look into space, the earlier we see into time. The galaxies nearest to us glow with the maturity of the present universe, but the tiny red specks at the edge of our vision show us a cosmos still in childhood galaxies, forming, merging, glowing with new stars. Telescopes that reach farther are not just instruments of distance, they are instruments of time travel. This is why the James Webb Space Telescope is so transformative. It can detect galaxies so faint and so distant that their light began its journey when the universe was still less than 1 billion years old. Webb is not only seeing far, it is seeing early, revealing the cosmic dawn. Light also carries another message, one woven into its very wavelength. As the universe expands, it stretches the light passing through it, pulling it into longer, redder wavelengths. This phenomenon, cosmic redshift, acts like a distance marker. The more stretched the light, the farther the galaxy. Each redshift is a kind of cosmic breadcrumb, telling us how far the light has traveled, how long it has been on its journey, and how much the universe has changed along the way. By examining how a galaxy's light is stretched into redder wavelengths, astronomers can estimate both its distance and the age of the light now arriving at our eyes. This simple shift, this cosmic elongation, has become one of the most powerful tools in cosmology. Redshift turns faint blurs into distance markers, transforming remote galaxies into precise indicators of how quickly the universe is expanding. But in the same motion, redshift also reveals a boundary. Beyond a certain distance, the expansion of the universe stretches light so dramatically that it slips beyond the range of our detectors. This is why the James Webb Space Telescope observes primarily in the infrared. The earliest galaxies have had their light stretched far out of the visible spectrum. Only by tuning into these longer wavelengths can we glimpse them. Even then, a point arrives where the stretching becomes so extreme that the light will never reach us at all. Space expands faster than the light can cross it, placing those galaxies forever outside our horizon. This limit exists not because the light is too weak, but because the universe is expanding too quickly. The boundary of sight is shaped by time, but also by motion. Another boundary comes from the cosmic microwave background, the faint glow left from the universe's earliest era. This light dates back to a time when the cosmos was only about 380,000 years old, when it had finally cooled enough for atoms to form and for photons to move freely. Before that moment, the universe was a blazing plasma where light was trapped, bouncing endlessly and unable to escape. Because of that, we can't see past this point with light at all. The microwave background is a kind of horizon, not a wall of matter, but a wall of opacity. It marks the beginning of visibility itself. Beyond that, we must infer and imagine, guided by theoretical physics rather than direct observation. It is one of the deepest limits built into the fabric of the universe. Because light defines what we can observe, the observable universe becomes a bubble centered on each of us. This doesn't imply we inhabit a special location. It simply means that light arrives from all directions, out to the same temporal limit. Every observer, whether on Earth, in another galaxy, or anywhere across the cosmos, would have their own bubble of visibility centered around them. The universe extends far beyond each bubble, but each horizon is personal, shaped by how long light has been traveling toward that specific place. The cosmos is both universal and intimate, immense in totality, but bounded individually by the physics of light. It's worth pausing to appreciate the sheer wonder of this. From a small world orbiting an ordinary star, we can peer billions of light years into the past. We can reconstruct the evolution of galaxies and clusters. We can detect the soft residue of the universe when it was less than 1 million years old. We can measure how galaxies recede from us and read the expansion of the universe in the stretching of their spectra. We can map the microwave background and see the cosmos as a glowing infant. All of this comes from light, this fragile ancient carrier of information. Without it, nearly everything we know about the universe would vanish. Light is our connection to the cosmos. It is the thread that ties us to the distant galaxies, to the early universe, to epochs we never lived through, but can still witness. Yet light also humbles us. It draws boundaries we cannot cross. We cannot observe anything older than the microwave background. We cannot see galaxies whose light hasn't had enough time to arrive. We cannot detect objects carried away faster than light by the expansion of space itself. Our view is shaped not by desire, but by physical law. The edges of vision are just as real as the stars we see. They are horizons woven into the structure of space-time. This tension between extraordinary reach and unbreakable limit is part of what makes astronomy so captivating. On one hand, we look farther than any generation before us could have imagined, capturing galaxies billions of light years away, charting the cosmic web, and catching the faint echo of creation. On the other hand, we know with certainty that beyond our horizon lies a vastness we can never reach, perhaps infinite to forever invisible. Light gives us clarity and mystery in the same breath. For someone standing beneath the night sky, that realization becomes deeply calming. Every star is a traveler whose light has crossed space to meet us. Every galaxy in a telescope is a preserved moment from long ago. The limits of sight remind us of the universe's immensity, but also of the fact that we are connected to it through every photon that reaches us. We are not outside the cosmos peering in. We are inside it, woven into it, seeing. With the only messenger that can cross the dark, the light that travels endlessly, carrying the universe to our eyes. When we pause long enough to reflect on light, on distance, and on the quiet boundaries of what we can see, a stunning picture already unfolds. Galaxies shining from billions of years ago, their light softened and stretched by the slow breathing of cosmic expansion, and a horizon that marks the outer limit of every signal that will ever touch our eyes. Yet even that, vast as it seems, is not the end of the story. In truth, that horizon is only the threshold to a deeper and more humbling realization. Because once we understand the boundary of sight, the next question emerges almost automatically. What lies beyond it? What does cosmic expansion really mean? And why are there galaxies? We will never ever see, not because they are dim, but because the universe itself is carrying them away faster than light can chase them. To sit with these questions is to step into one of the most profound truths in cosmology. Most of the universe is already outside our reach and always will be. The idea that the universe is expanding has been with us for a century, but its implications still feel surreal. In the 1920s, Edwin Hubble and his colleagues noticed something strange. Distant galaxies were drifting away from us, and the farther they were, the faster they seemed to recede. Their light was stretched toward the red end of the spectrum, a cosmic signature of motion. This realization changed everything. It revealed that the galaxies were not drifting apart through space the way sparks scatter from a fire. Instead, space itself was stretching, and the galaxies were simply being carried along with that flow. On small scales, gravity keeps stars in galaxies, galaxies in clusters, and clusters in loose associations. But on scales larger than these gravitational islands, expansion takes over. It pulls the cosmic web outward, causing the vast distances between its filaments and voids to grow. And this stretching leads to a consequence that at first seems impossible. Somewhere far enough away, the expansion becomes so rapid that galaxies are being carried away from us faster than light can travel. This doesn't break relativity because nothing is moving through space faster than light. It's space itself that is growing, increasing the distance between us and those galaxies faster than any photon could ever hope to cross. The result is profound. There are galaxies whose light emitted today will never reach us. Not in a million years, not in a trillion years, not ever. These galaxies lie beyond our cosmic event horizon. They are permanently inaccessible, forever outside the region of space from which information can reach us. They are not just unseen now, they are unseeable in principle. This event horizon is not the same as the horizon of the observable universe. The observable universe is defined by how far light has already traveled since the Big Bang. The cosmic event horizon is defined by how far light will ever be able to travel in the future. Because the expansion of the universe is accelerating, driven by the mysterious pressure we call dark energy, the event horizon lies significantly closer than the observable horizon. The expansion is speeding up, not slowing down. The more the universe grows, the more rapidly distant galaxies slip beyond the reach of light. This means something remarkable. The night sky we see today is the richest it will ever be. Over trillions of years, distant galaxies will fade from view, red shifting into invisibility as the expansion stretches their ancient light beyond all detection. The universe is opening, but our window into it is slowly closing. And yet, this realization brings a strange kind of peace. Even though much of the cosmos lies forever beyond our sight, the part we can see is already infinite. To the imagination, billions of years of history carried to us on ancient light, whole galaxies whispering their stories across time. We live inside a universe that is expanding beyond our touch, yet still close enough to speak to us through light. And that light, the quiet traveler crossing the dark, reminds us that we are not isolated. We are part of the cosmic flow itself, moving with it, carried by it, and illuminated by it. There are galaxies whose faint light still reaches us today, light that began its journey billions of years ago, but we will never witness what those galaxies look like now. The photons they are releasing in this moment will never cross the widening gulf of space to meet our eyes. They are already being carried away on a current of expansion so swift that no beam of light can ever swim upstream to reach us. What we see of them are ancient snapshots, frozen echoes of a reality long gone, while their present and future drift permanently beyond our sight. It is one of the most haunting truths of a universe that grows as it ages, even though the cosmos seems full of galaxies, most of them are already lost to us. With every passing era, more and more slip across the invisible boundary of the cosmic event horizon. Tens of billions of years from now, everything beyond our small gravitational neighborhood will fade away entirely. Their light will stretch into wavelengths too long and too faint to detect until only the dim glow of the galaxies bound to our local group remains. For future observers, creatures who may live long after our time, the universe will look like a lonely archipelago floating in darkness. The rich cosmic web we now observe, the vast filaments of galaxies threading across space, will no longer be visible. The universe we see today is a gift of timing, a brief window in cosmic history when the sky is still full of messages and still transparent enough for us to read them. Far ahead, that clarity will be gone. Realizing this can be unsettling, but it also centers us. It tells us that our understanding of the cosmos is not only shaped by what exists out there, but also by when we happen to live. The horizon is not fixed. It shifts, expands, and contracts in what is possible to witness. As new light arrives from unimaginable distances, the observable region grows. But at the same time, expansion pulls distant galaxies so far away that a different kind of shrinking occurs, a shrinking of what we will ever be able to see. It feels like standing on a coastline at dusk, watching ships appear on the horizon, while others sail into the mist, fading from sight forever. The ocean is full of ships, but only a few happen to pass within view. The rest remain real, but unreachable. When astronomers discovered in the 1990s that the universe's expansion is not slowing down, but accelerating, the image became even sharper. For decades, scientists wondered whether gravity would eventually halt the expansion and pull everything back together. Finding that expansion is actually speeding up changed the nature of the question entirely. It is no longer about whether galaxies will drift apart. It is about how quickly they slip away forever. The force behind this acceleration is the mysterious phenomenon called dark energy, which makes up roughly 70% of everything in existence. We do not yet know what dark energy is. We only know how it behaves like a pressure that stretches space itself, pushing galaxies farther apart and ensuring that the expansion will not only persist, but intensify. This guarantees that the cosmic event horizon is not an abstract idea, but a permanent and unavoidable feature of our future. To exist in an expanding universe is to live within layers of horizons. One horizon is set by the age of the cosmos, the farthest distance light has traveled to reach us. Another is set by the accelerating expansion, the farthest distance light will ever be able to travel. We live in the space between these horizons, in a bubble of visibility that is slowly shifting around us, reminding us that our cosmic view is precious, temporary, and deeply dependent on the moment in which we look. These horizons remind us that our perspective is not central, not privileged, simply shaped by the physics that cradle us. The only light we can see is the light that has managed to reach this moment. The only galaxies we can witness are the ones whose ancient signals have survived the widening gulf of an expanding cosmos. Everything else is not hidden by intention, but carried gently beyond sight by the universe's own motion. In this way, the cosmos is not infinite to our perception, even if it may be infinite in its true nature. Our vision is framed by the finite speed of light and the quiet, relentless stretching of space. But this boundary is not something to mourn. If anything, it makes the view we have right now extraordinary. To recognize that galaxies are slowly slipping beyond reach is to understand that we inhabit a rare era of cosmic transparency, a fleeting interval where the universe still reveals its origin story. Today, the sky still carries the echo of the Big Bang. Today, the cosmic web still glows faintly across billions of light years. Today, we can see the expansion measure the structure and trace the history written into the fabric of space. Far into the future, observers born in distant epochs will not share this view. To them, the universe will appear sealed off and enclosed, filled only with the handful of galaxies bound to their local group. The cosmic microwave background will have faded into an undetectable whisper. The expansion will no longer be measurable. Their cosmos will seem small static, isolated its true immensity, hidden by time. We, however, live in a narrow window when the universe is still open, still clear, still luminous. That realization makes our moment in cosmic history feel brief and indescribably precious. It also transforms what we mean when we speak of distance. Saying that a galaxy is a billion light years away is not merely describing how far its light has traveled. It is describing a distance reshaped, stretched, and rewritten by cosmic expansion. The galaxy, whose ancient photons reach us now, is no longer where it was. It has drifted much farther away in the time its light has been crossing the dark. This is why cosmology distinguishes between different kinds of distance: light, travel distance, co-moving distance, proper distance. Words that sound abstract, but each revealing a quiet truth. Distance in an expanding universe is not fixed. It breathes, it changes, it grows. Galaxies are carried outward on the tide of expansion, some slowly, some swiftly, some already beyond any hope of contact. To sit with this is to accept that the universe is not something we can ever map in absolute completeness. It is something we can glimpse, something we can measure, and put something we can describe with increasing clarity, but never something we can fully contain with sight alone. There will always be regions that lie beyond the reach of light, always photons that will never arrive, always galaxies whose present and future fall permanently outside our cosmic horizon. And even in that limitation, there is a quiet beauty. The universe keeps its mysteries, not to frustrate us, but to remind us of our place within something vast, an ocean of being where visibility is temporary but wonder is endless. Our maps are incomplete, our understanding always held within gentle limits, and our horizons shaped by laws older than stars. Yet inside those limits, the view remains astonishing. Within our small window of clarity, we can witness billions of galaxies, trace billions of years of cosmic memory, and collect the fading afterglow of creation itself. We can measure the universe's expansion, sense the invisible pressure of dark energy, and map the delicate strands of the cosmic web. Even if most of reality lies beyond our reach, what we can see is enough to fill any mind with wonder. At first, the idea of galaxies drifting out of view can feel lonely, as if the universe were slowly dimming around us. But there's another way to understand it. Those galaxies aren't abandoning us. We're all simply being carried by the same expansion, woven into the same fabric, moving along the same cosmic tide. Nothing is truly separating from anything else. We remain connected through the light that has already arrived through the shared history imprinted across space-time. Even when a distant galaxy crosses the horizon, the ancient light it sent long ago still reaches us, like a ship disappearing over the ocean but leaving ripples in the water. The universe expanding beyond reach does not erase the past, it only sets the boundaries of what the future will allow us to see. When we talk about expansion, we are really talking about time, about perspective, about the delicate balance between what is visible, what is hidden, and what will always remain beyond the final edge of sight. The observable universe is our window into what was. The event horizon marks the limit of what will ever be seen. Between these two horizons lies our present moment, a rare interval when galaxies still glow in our night sky, still whisper their stories, still send their ancient messages through the dark. To live now is to exist in a brief era of cosmic openness when the universe is still transparent, still illuminated, still willing to reveal its structure. And even as expansion carries most of its wonders beyond reach, the part we can see is more than enough to remind us that we belong to something vast, mysterious, and indescribably beautiful. And once we sit with that idea, another question rises almost naturally. Why is the universe so much larger than our own Milky Way? Why does reality stretch across 93 billion light years while our galaxy spans only about 100,000? The contrast is overwhelming. The Milky Way is already unimaginably large, yet it becomes a tiny grain on the shoreline of a cosmic ocean when compared to the whole. To ask why the universe is so much bigger than our galaxy is to explore history, physics, and the forces that shaped everything from the smallest scales to the largest. There is no single explanation, only a tapestry of reasons woven together across time. The first and most fundamental answer lies in the universe's origin, the moment we call the Big Bang. It was not an explosion in empty space. It was the birth of space itself unfolding everywhere at once, stretching, expanding, and carrying all future galaxies within it. The Milky Way formed billions of years later inside that already expanding fabric. The universe grew vast because space itself continued to expand long before our galaxy even existed, and in that expansion, the enormous scale of the cosmos was set not as a stage built around us, but as the natural consequence of space unfolding from its earliest moments. From a beginning so hot and dense that even atoms could not exist, the universe expanded and cooled, gradually creating conditions gentle enough for matter to form, for atoms to settle into being, and for light to finally move freely through space. That expansion has continued quietly, steadily for 13.8 billion years. And across such immense stretches of time, even a slow stretching of space becomes unbelievable in scale. Because space has been unfolding all this time, the cosmos has grown far larger than any individual structure living inside it. Galaxies formed as small, local concentrations of matter floating within a fabric that never stopped expanding. They are grand on their own scale, but tiny compared to the space that holds them. Another reason for this gulf in size comes from how matter gathered after the Big Bang. In the beginning, matter was spread almost perfectly evenly, interrupted only by tiny ripples, small fluctuations in density. Gravity magnified those ripples just enough to let matter fall inward, drawing gas into the regions where galaxies and clusters would eventually emerge. But the sizes of these condensed regions were limited by the physics of the early universe. Galaxies could only grow until their own gravity stabilized them. Beyond that scale, gravity didn't create bigger galaxies. It connected existing ones together into clusters and superclusters. Galaxies are simply one level of structure, shaped by what gravity can bind. The universe itself is not bound in that same way. Its size is set not by gravity, but by the age and rate of expansion. Dark matter adds another layer to this story. Every galaxy sits inside an invisible halo of dark matter structures that outweigh the stars by a factor of 5 or more. These halos define how large a galaxy can become. Beyond the halo's reach, matter is not bound to the system. The Milky Way's dark matter halo may stretch a few 100,000 light years across, but even that is minuscule compared to the universe. Galaxies are limited by the gravitational arms of their halos. The universe is limited only by time. These two scales arise from entirely different processes, which is why the difference between them is so extreme it feels almost impossible to compare. There is also the simple truth that galaxies are not isolated objects. They belong to larger families of structure, nested arrangements linked by gravity and dark matter. Our Milky Way belongs to the local group. The local group belongs to the Virgo cluster. Virgo belongs to the Laniakea supercluster, and these superclusters weave together into the vast cosmic web. Each step upward expands the scale until finally we are talking about the observable universe itself. In this sense, asking why the universe is so much larger than a galaxy is like asking why the ocean is so much larger than a single wave. The wave is shaped by the ocean, held by it, created by forces larger than itself. A galaxy is no different. It's a ripple inside a cosmic sea, formed and defined by the universe that surrounds it. Time deepens this contrast. The universe has had an almost 14 billion years to expand, cool, and grow into the structure we see today. Galaxies formed hundreds of millions of years after the Big Bang and have been evolving ever since. They are younger than the universe, smaller, because they are children of its physics. If the cosmos had existed for only a short time, galaxies might not yet exist at all, or they might be far smaller still, gathering matter. The universe is so large because it has had time to become large. Galaxies are smaller because they are products of gravitational collapse, a process limited in scale. Another way to see the difference is to consider what each one is made of. A galaxy is a bound system. Stars, gas, dust, and dark matter held together by gravity. The universe is not a bound structure. It is the fabric in which all bound structures sit. It is not one more object inside a larger container. It is the container itself. Space-time is the stage on which everything else performs. And stages are always larger than the actors that stand upon them. The size of a galaxy is shaped by balance, gravity, drawing everything inward, while the motion of its stars pushes back just enough to prevent collapse. The size of the universe is shaped by something entirely different: expansion, the quiet stretching of space itself with no boundary to contain it. One structure is bound, the other unbound. One is local and limited, the other global and ever growing. Their scales diverge because their very natures diverge. It's tempting to wonder why galaxies couldn't grow to fill all of space, why there aren't just one or two titanic galaxies instead of trillions of smaller ones. But the physics of the early universe ruled that out long ago. If all matter had collapsed into a single colossal system, the cosmos would have lost the richness we see today. No scattered galaxies, no cosmic web, no diversity of shapes and histories. Instead, the tiny ripples present in the early universe guided matter into countless smaller clumps rather than one overwhelming structure. Galaxies became the natural scale for structure. The universe itself became the natural scale for existence. Their difference in size is part of what allows the cosmic beauty. We observe the variety of spirals and ellipticals, the networks of clusters, the vast voids between. Perspective shapes this contrast too. From where we stand, the Milky Way feels infinite. 100,000 light years is far beyond any journey we could ever take. Even our closest neighbor, Proxima Centauri, is more than 4 light years away, already impossible with our current technology. The galaxy feels impossibly large, because to us it is. But from the universe's point of view, the Milky Way is tiny, one glowing island among trillions, one wave, lost in a limitless sea. Scale is always relative, and the gap between galaxy and universe reminds us that size depends on the viewpoint. This enormous difference in scale isn't just scientific, it carries meaning. It reminds us that our galaxy, though immense to our eyes, is not the center of the story. It is one chapter in a much larger narrative. This doesn't make the Milky Way any less significant. In truth, knowing the vastness beyond makes our home feel even more precious, our own island of stars in a boundless ocean. and the universe's immensity opens the door to possibilities beyond imagination. If there are trillions of galaxies, each with billions of stars, then the potential number of planets and perhaps life multiplies into staggering numbers. The universe being far larger than our galaxy is not simply a matter of measurement, it is a measure of potential. It means the story of existence is not confined to one place, but scattered across trillions of homes. It means wonder is multiplied, discovery is multiplied, and meaning itself stretches across cosmic distance. The universe is vast because it carries everything. The galaxy is smaller because it is one pattern woven into a much larger tapestry. So when we ask why the universe is so much bigger than our galaxy, the answers layer together. Because expansion has been unfolding for billions of years. Because galaxies are limited by the physics that bind them. Because cosmic structure builds itself from the bottom up. Stars form galaxies. Galaxies form clusters. Clusters link into superclusters, and all of it hangs within the universe's fabric. Because matter collapses on small scales, but spreads across the largest ones. Because the universe is the canvas, and galaxies are the strokes painted across it. The contrast in size is not an error or a mystery. It is a natural expression of how the cosmos works. The Milky Way may be small compared to the universe, yet it is overwhelmingly vast compared to us. And the universe, though immense, is still something we can touch with our measurements, our imagination, and our light. Scale is always relative, and meaning has never depended on sheer size. The Milky Way is the home that shaped us. The universe is the wider field that holds that home, and knowing both gives us a clearer sense of who and where we truly are. It lets us rest gently between smallness and belonging, between being a single part and being woven into the whole, between the galaxy that shelters our star and the cosmic expanse that enfolds it. When we pause to consider why the universe dwarfs the Milky Way so completely, the figures themselves can almost dissolve into abstraction. A cosmic horizon, 93 billion light years wide, roughly 2 trillion galaxies suspended within that sphere, trillions upon trillions of stars scattered along filaments that stretch farther than light has had time to cross. In comparison, our galaxy is a modest islet of light. Against the Milky Way, Earth is a tiny breath of dust, and against Earth, each one of us is a momentary flicker. To sit with this knowledge is to confront not just the mathematics of scale, but the meaning hidden inside it. What does such immensity imply for us? How should we hold the realization that the cosmos is older, broader, deeper, and stranger than anything our daily lives would ever reveal? For many, the first sensation is humility. Stand beneath a truly dark sky, far from the noise of cities, and the stars already whisper how small we are. Then imagine that each of those points of light is only one among hundreds of billions in our own galaxy, and that our galaxy is only one among trillions in the observable universe. The feeling of smallness deepens. We become brief sparks in an ancient, unfolding tapestry. But humility does not equal insignificance. For some, That vastness feels like erasure, a reminder that human worries and hopes are minuscule compared to the sweep of cosmic history. Yet for many others, humility widens into clarity. To be small is not to be meaningless. It is to be part of something so immense that our presence, however brief, participates in a story far grander than our individual moments. This shift in perspective can soften how we view our lives. The weight of everyday frustrations, deadlines, stresses, and disappointments may still be felt, but the scale changes. They lose some of their heaviness in the presence of a universe where galaxies drift apart, stars ignite, and worlds form and vanish across unthinkable distances. Our challenges matter, but not in an absolute way. They are threads within a much larger weave. To realize that galaxies are accelerating beyond our reach, that stars are forming in nebulae thousands of light years away, that cosmic structures grow and fade across billions of years, is to remember that our personal stories are not the whole reality. We exist inside a universe incomprehensibly larger than our individual concerns, and that knowledge itself can be calming. We are part of something vast. We belong to something ancient. We arise within a cosmos still unfolding, and sometimes that reminder becomes a kind of quiet medicine. It softens the pressure we place on ourselves, loosens the grip of urgency, and opens a little more room for gratitude to enter. Because the same vastness that humbles us also awakens wonder to realize that the cosmos holds not just countless stars, but trillions of galaxies, is to realize that the universe is not simply large, it is generous. It overflows with light, with structure, with possibility. Each galaxy shelters billions of suns. Many of those suns likely host worlds of their own, and within those worlds may be places where chemistry stirs, where complexity grows, where consciousness might one day rise and look back at the stars just as we do. The immensity multiplies the chance that we are not alone. It becomes difficult to believe that awareness happened only here on one small planet orbiting one ordinary star. For many, that thought is electrifying. It transforms the universe from empty space into a vast canvas of potential stories. Civilizations we will never meet, histories that unfold silently across distances too great to cross. The vastness stops feeling like emptiness and becomes a promise. And yet, the same immensity that inspires awe also highlights our fragility. Earth is a small, delicate oasis floating in an ocean of darkness. The conditions that cradle life are narrow temperature atmosphere, distance from the sun, a billion-year balance of geology and chemistry. When seen against the wider cosmos, our planet becomes a rare sanctuary. That realization deepens our sense of responsibility. If the universe is overflowing with galaxies, but possibly sparse in life, then the life here is priceless. Our world is not disposable. Our future is not guaranteed. Our choices shape whether this rare haven endures. The vastness also stirs philosophical questions that humans have carried for centuries. If the universe towers so far above the scale of our galaxy, what role do we play within it? Are we a cosmic accident or a natural expression of the laws that govern every star and every world? Is consciousness a rare spark or one of countless lights scattered across the dark? The universe does not answer these questions explicitly, but it frames them in a way that makes them feel profound. Because galaxies do not examine themselves, stars do not ponder their origins. But somehow, on a small world around a modest star, in a typical spiral galaxy, matter became conscious enough to measure the universe and wonder about its meaning. That capacity to ask, to reflect, to interpret is extraordinary. It may be the gift we bring to the cosmos. Another way to approach the immensity is through connection rather than comparison. Even though the universe is immeasurably larger than we are not separate from it. The atoms that make up your bones were forged in ancient stars. The oxygen you breathe was born in the nuclear hearts of suns. The hydrogen in your cells is a relic of the Big Bang itself. Every moment, every heartbeat, every thought is an expression of the universe acting through you. You are not an outsider observing from a distance. You are a participant, a structure the cosmos assembled to briefly look back at itself. The vastness becomes familiar when seen this way, not an expanse to fear, but the larger body of which we are a small but inseparable part. For many, this realization is deeply comforting. Even though our lives are brief and our scale tiny, we are not isolated. We are temporary gatherings of atoms that have cycled through stars and will one day return to them. Our awareness is the cosmos awakening within a human frame. When you look at the night sky, you are not staring at something foreign. You are the universe recognizing its own expanse. This does not make us insignificant. It makes us remarkable precisely because we can understand it. And this understanding also reshapes how we imagine the future. Human time is counted in years, decades, centuries. But on cosmic time, stars burn for billions of years, and galaxies evolve over epochs so long they blur into geological tides. After resting with the idea of what cosmic vastness means for us, our attention naturally drifts toward an even deeper question. Where exactly do we fit inside all of this? If the universe holds trillions of galaxies, if the Milky Way is just one luminous island drifting in an endless sea of others, and if the observable cosmos stretches across 93 billion light years, then what does it truly mean to be human within such an expanse? The picture is both humbling and strangely soothing. Physically, we are small, so small it almost defies comparison. Our lifetimes are brief flickers when measured against billions of years. And yet, in spite of this smallness, we are here able to look outward, able to measure, to question, to contemplate our place in something so large our minds can only brush against its edges. The first layer of our place is physical. We live on a small blue world orbiting an unremarkable star tucked into a quiet corner of one spiral arm of the Milky Way. Our star is ordinary. Our location is ordinary. The region we inhabit, often called the Orion Spur, is neither the center nor the outskirts of the galaxy. It is simply a middle lane in a vast rotating disk. Around us, stars gather like distant lanterns, scattered across every direction. Many host planets. Some may host life, and the Milky Way itself curves above us like a pale ribbon, a reminder that we are inside this structure, not separate from it. Physically, our position is modest, a tiny point in a galaxy filled with hundreds of billions of suns. And yet, even in this modest position, there is belonging. We are not standing outside the universe looking in. We are woven into it, carried within it, shaped by it. The second layer of our place is temporal. The universe has existed for 13.8 billion years. Earth emerged roughly 4.5 billion years ago. Humans as a species appeared only a few 100,000 years ago, and everything we call history, every civilization, every story, every memory fits inside the last small sliver of that time. Against this backdrop, our existence is brief, but our timing is remarkable. We live at a moment when the universe is still lit from end to end, when galaxies still shine toward us, when the whisper of the Big Bang still glows across the sky as the cosmic microwave background, when expansion can still be measured, when the universe is still revealing its structure rather than hiding it behind horizons. In the far future, much of this visibility will fade. Entire galaxies will drift beyond sight forever. But we exist in the narrow window when the cosmos is clear enough to be understood. That timing alone makes our moment feel extraordinary. The third layer is cognitive. We are not the largest beings in the universe, not the longest lived, not the most powerful in any cosmic sense. But we are among the very few, perhaps the rare few, able to wonder at all. Galaxies do not think about themselves. Stars do not ask what they are made of. Gas clouds do not ponder the nature of time. But we can. Somehow, in one tiny corner of one galaxy, consciousness has awakened enough to look out across billions of light years and ask what it all means. This ability is not trivial. It may be the most extraordinary thing about us. We are small, but we are aware. And awareness in a universe this vast is not a weakness, it is a wonder. Galaxies drift into one another, merging and reshaping over spans of time, so long they almost feel outside the rhythm of time itself. And while these colossal events unfold across eons, the universe continues its gentle stretching and expansion that will carry on not just for billions, but for trillions of years to come. Measured against that immensity, our presence is a brief flicker, yet a remarkable flicker. We happen to exist in a rare era when the cosmos is still glowing with its earliest light, when the afterglow of the beginning still hums across the sky, and when far off galaxies still manage to send their ancient messages to us. One day, much of this cosmic visibility will fade as expansion sweeps it away. But now, in this narrow and precious window, the universe remains transparent enough for us to witness its story, and that clarity is its own quiet kind of gift. It reminds us that knowledge itself is temporary, a momentary alignment between what the universe reveals and what we are able to perceive. For many, the scale of the cosmos alters the way meaning is understood. It's tempting to assume that size equals importance, that the smaller something is, the less it matters. that a short life carries little weight against billions of years. But meaning has never depended on scale. A brief breath can change a lifetime. A single act of kindness can shift a human heart. A short existence can be filled with depth, love, curiosity, purpose. Our significance doesn't dissolve because we are small, it deepens because we are conscious, because we can feel beauty, hold empathy, create intention, and experience but with awareness in a universe that otherwise moves in silence. In this way, the vastness doesn't erase meaning, it expands it. It shifts value away from physical size and toward presence, toward the simple fact that we are here awake, able to interpret the universe through the lens of experience. We matter because we perceive, because we wonder, because we can care in a cosmos that is otherwise indifferent. This recognition also softens how we view each other. When we truly absorb the fact that every human being shares the same fragile planet, orbiting the same unremarkable star, tucked into the same slender arm of the same galaxy, the boundaries we draw begin to lose their intensity. They still exist, but they feel smaller. Conflict shrinks when placed beside a backdrop of trillions of galaxies. Disagreements lose their weight when measured against the age of the cosmos. The universe will not resolve our struggles, but it does offer a kind of gentle perspective. It asks us to remember that cooperation matters more than division, that compassion is more enduring than rivalry, that we are all sharing the same small cradle, drifting through a great ocean of darkness. So, what does this vastness mean for us? It brings humility because our physical scale is tiny. It brings perspective because our challenges are brief. It brings wonder because the cosmos is overflowing with possibility. It brings responsibility because our world is rare and fragile. It brings connection because our bodies are built from atoms forged in ancient stars. It brings gratitude because we live in a fleeting era when the universe still reveals its structure, and it brings possibility, limitless, expanding possibility, because the cosmos holds more than our minds will ever grasp. As this understanding sinks in softly, the vastness stops feeling threatening and begins to feel comforting. It doesn't diminish us. It wraps around us like a quiet tide. It reminds us that we belong to something immeasurably larger than anything we can measure, and that being small within such grandeur is not a weakness. It is simply our truth. To exist in such a universe is to live with perspective, with humility, with awe. It is to recognize that we are woven into a cosmos far beyond our sight, and that belonging to it, even in the smallest way, is already enough. And yet somehow we do possess this ability. Our minds have evolved to the point where we can chart the cosmos, measure its expansion, trace its structures, and quietly wonder about our place within it. That ability alone is astonishing. It gives us a role not defined by size or power, but by awareness. The ocean of galaxies may be immense, but the fact that we can recognize it, contemplate it, and give it meaning places us in a unique relationship with the universe. Our place is not merely physical or temporal, it is conscious. We are participants who can sense the ocean we drift within. Our place is also defined by relationship. To be human is not to stand apart, but to exist in connection with each other, with the earth, with our galaxy, and with the vast universe itself. Every atom in our bodies was formed in starlight. The oxygen we breathe, the iron circulating in our blood, the calcium in our bones, the carbon that forms our cells, all of it was created in the cores of ancient stars and scattered across space by explosions that lit the early cosmos. We are made of stellar remnants. Yes, but even more deeply, we are made of the universe's own fabric. The laws that sculpt galaxies also shape us. The expansion that stretches clusters apart influences us as well. We are not separate from the cosmos. We arise from it. To recognize this is to feel a quiet and profound belonging, one that dissolves the illusion of separateness. Perspective is another dimension of our place. When we look outward and witness the vast sweep of galaxies, we don't just learn about them, we learn about ourselves. The immensity may make us feel small at first, but it also reminds us that significance isn't measured in kilometers or years. A galaxy is not meaningful because of its size. It is meaningful because it exists, because it adds its own light to the cosmic tapestry. In the same way, our value comes not from scale, but from presence. We matter because we are part of the whole. The sea of galaxies doesn't diminish us, it situates us. For some, this perspective inspires awe, a sense of being part of something far larger and more magnificent than anything we can build or imagine. For others, it stirs discomfort. Smallness can feel unsettling, but that discomfort eases when we remember that awareness itself may be rare. Among trillions of galaxies and countless worlds, we do not yet know how common consciousness truly is. Maybe it fills the universe, or maybe it is scarce. Perhaps we live in one of the few places where the cosmos has awakened to the point of observing itself. If that is true, then our place is not trivial at all. It is remarkable not in scale, but in sensitivity in the simple fact that we can know. There is also an ethical dimension to our place. To understand that we live on a fragile planet orbiting a modest star in a quiet arm of a typical galaxy is to recognize a profound responsibility. Earth is our home, rare, delicate, and precious. Against the vast backdrop of galaxies, it is irreplaceable. The universe may contain endless expanses, but our small world is singular. To fail to care for it would be to forget where we stand completely. The vastness teaches humility and wonder, but it also teaches stewardship. And our place is not fixed. The cosmos is changing, and so are we. The Milky Way drifts toward Andromeda. Galaxies collide and reshape. Clusters pull on one another. Superclusters flow along unseen cosmic rivers. We exist within a universe defined by motion, by transformation, by evolution, on scales large and small. And our own story, brief as it is woven into that same movement. We too are part of this immense drift, carried gently by the same cosmic currents, shaped by the same unfolding story. Our position isn't a fixed point, it is a moment in motion, a single chapter woven into a narrative far older and far wider than anything we can see. To recognize this is to understand that our place is both modest and magnificent at the same time. Modest because we are not the center of anything, magnificent because we are participants in the universe's ongoing creation, a living part of its history. It's natural to wonder whether this vast ocean of galaxies cares about us. The honest answer is no, not in any human sense of intention or purpose. The cosmos is neutral. Galaxies merge and unravel without noticing our lives. Stars are born and extinguish themselves whether or not anyone is here to witness them. Expansion continues with or without our measurements. Yet, despite this cosmic indifference, something remarkable happens. Our awareness gives the universe a mirror. The sea of galaxies may not care, but we do. And that caring our attention, our wonder, our curiosity creates meaning the universe cannot give itself. Our place is not assigned by the cosmos. Our place emerges from our ability to understand it. So, what then is the human role in a universe filled with trillions of galaxies? It is small, undeniably delicate, and incredibly brief. Yet it is also conscious, interconnected, and quietly extraordinary. We are not cosmic rulers, not the center, not the largest or strongest force in existence. We are a thinking species on a small planet orbiting a typical star tucked into a modest spur of a single galaxy among uncountable others. And still, we are something remarkable, the universe becoming aware of itself, a moment of reflection in a sea of silence, a spark of understanding in a dark that stretches forever. Our purpose is not to steer the cosmic ocean, but to witness it, to marvel, to feel, to explore, to ask. In that sense, our awareness is every bit as meaningful as a galaxy's light because it turns the vastness into something more than empty distance. It transforms it into wonder. As this awareness settles, the imagery of the galactic ocean shifts subtly. It stops being a place in which we drift helplessly and becomes a place from which we arise. A sea whose water runs through our cells, a tide whose rhythm we inherit, a story whose chapters include us. Our place may be small, but it is genuine. Our time may be brief, but it belongs to us. Our role may not be the entire narrative, but it is a thread woven into its fabric, and that is enough. To know this is to relax more deeply into the immensity around us, to feel the sea of galaxies not as something that erases us, but as something that holds us, embraces us, connects us to everything else that exists. After traveling so far across scales, across distances, across time itself, the path naturally softens. We have moved from our tiny solar system to the spiraling arms of the Milky Way, from our single galaxy to clusters and superclusters, and finally to the edges of the observable universe. Along the way, we've reimagined the Milky Way as an island glowing in a cosmic archipelago, counted the stars that fill it, traced the empty spaces between galaxies, followed the gravitational rivers that guide clusters, measured distances using nothing but the journey of light, and held the entire universe beside the single galaxy we call home. With each step, the scale widened, and with each widening, our perspective deepened. But now, at the edge of this long cosmic journey, there is room for something softer, something closer to the heartbeat of our own experience, something quieter, something human. At this point, the question isn't really about numbers anymore. It isn't about calculating distances or comparing sizes. It shifts into something quieter, something more inward. It becomes a question of how we live, with this understanding how it feels to sit beneath a sky that we now know stretches far beyond anything the mind can fully grasp. The first feeling that rises is a kind of surrender. When you realize just how immense the universe truly is, how the Milky Way is only a tiny swirl in a cosmic ocean, and Earth just a grain within that swirl, there comes a moment when your instinct to comprehend everything simply loosens. The figures are too enormous to hold it all at once. 93 billion light years, 2 trillion galaxies, a septillion stars, and beyond that, perhaps no boundary at all. These aren't facts we can store neatly in memory. They are more like waves too broad to contain, yet soothing to lie beneath. And so instead of trying to hold the infinite tightly, we allow it to move through us. Like reclining on warm sand, listening to the steady rhythm of the ocean, knowing full well that you will never cross it entirely, yet still finding comfort in its sound, its presence, its vastness. The infinite is not something we possess. It is something we witness in passing, and those brief moments of recognition are enough. Another feeling is perspective. When we sit beneath a sky that stretches beyond imagination, our own tensions and worries subtly shift. They don't disappear. Our lives remain real and valuable, but they lose their sense of total urgency. The frustrations, the deadlines, the conflicts that feel overwhelming during the day soften when viewed against billions of years and uncountable stars. Not because they aren't important, but because they no longer feel like the entire story. The immensity creates a kind of breathing room. It gently reminds us that life is larger than any single moment of stress. The universe has been unfolding for eons. Stars have been forming and fading long before we arrived, and they will continue long after we are gone. And in that continuity, there is something deeply calming. Beneath the infinite, we feel anchored even when our individual paths twist and change. There is also a surprising sense of belonging. At first glance, the infinite can make us feel insignificant, as if we are tiny figures standing at the edge of an overwhelming expanse. But the more we reflect on it, the more a different truth emerges. We are not separate from that expanse at all. We exist within it. We are shaped by it. The atoms that form our bodies were born in ancient stars. The oxygen we breathe, the water we drink, the nutrients we absorb, all come from the same cosmic processes that build galaxies. We are not an outsiders looking at the universe. We are expressions of the universe, self-aware arrangements of cosmic matter briefly gathered into human form. To rest beneath the infinite is to remember that we belong to it completely, that we are not alien to the cosmos, but continuous with it, woven from the same fabric, luminous with the same origins. The infinite is not above us. It is within us. It is what we are made of. This sense of belonging carries a quiet warmth of its own. When you understand that you are part of something immeasurably vast, the feeling of isolation softens. Even on nights when you feel alone, you are surrounded by a cosmos overflowing with light. The galaxies scattered across the dark are not distant strangers. They are reminders that the universe is full, not empty, alive, not silent. Their glow drifts across unimaginable distances just to reach your eyes. And in that glow is reassurance, a sense that the infinite is not a void at all, but a presence, a fullness, an endless field of possibility. Under such a sky, the darkness becomes a kind of shelter. The night wraps around you like a blanket, stitched with constellations, each point of light, a quiet reminder that existence stretches far beyond worry or fear. It turns the sky from something cold into something comforting, a vast canopy under which you can breathe a little deeper. There is also a gentler layer beneath all of this, a form of acceptance that grows naturally in the presence of something so immense. The universe contains mysteries. We will never solve horizons. We will never cross distances our minds can barely imagine. There will always be unanswered questions, always realities hidden behind cosmic fog, always truths that remain just beyond the reach of sight. Early on, this can feel unsettling, as if meaning requires total understanding. But acceptance brings ease. We do not need to solve every mystery to feel at home in the universe. We do not need to see everything to belong to it. The infinite is not weakened by its unknowns. The unknowns are what make it infinite. To rest beneath such vastness is to allow yourself to not know and to find comfort in that, to let wonder breathe, to understand that the questions themselves have value, and then there is time. Our lives are brief, measured in decades, not eons. Yet, when we sit with the scale of the cosmos, the brevity becomes less of a burden and more of a reminder. Stars burn for billions of years. Galaxies evolve over unimaginable spans. The universe has been expanding for nearly 14 billion years and may continue for trillions more. Against that timeline, our lives are small, but small does not mean meaningless. A moment can matter simply because it exists. A star does not need to shine forever to leave its mark. It matters because it shines at all. In the same way, our consciousness, however brief, is still extraordinary. This perspective naturally gives rise to gratitude. To exist at all, to be alive in this instant, aware breathing capable of looking upward and reflecting on galaxies, is astonishing. The odds that you would be here with this mind and this awareness at this moment in cosmic history are beyond calculation. Gratitude doesn't erase difficulty, but it balances it. It softens the edges. It reminds you that this brief window of awareness, this short chance to witness the universe, is a gift. And perhaps the deepest feeling the infinite offers is peace. Not because the universe is gentle, it is full of forces capable of tearing stars apart, but because its scale is steadying. The cosmos unfolds on a timeline far beyond our personal concerns. Stars will rise and fade, whether or not we notice. Galaxies will drift and merge regardless of our fears. Expansion will continue long after our civilizations vanish. None of it depends on us, and none of it is threatened by us. There is peace in remembering this, peace in knowing that existence is larger than any single worry, peace in understanding that you are part of a story vast beyond measure and that your presence within it, however brief, is real, meaningful, and deeply connected to everything around you. In a world where uncertainty seems to rise and fall like weather, the universe offers a different kind of stability. It remains vast, unhurried, and steady, and somehow we remain a part of that steadiness. To rest beneath the infinite is to feel carried by something larger than effort, larger than worry, not in control, but never excluded, more like a traveler moving gently through time and space, held inside a story far older than our own. So, what does it truly mean to rest beneath the infinite? It means letting go of the need to grasp every detail. It means allowing perspective to soften the edges of our days. It means remembering that we belong to something larger than the concerns of a single moment. It means finding comfort in presence, peace in scale, and acceptance in the mysteries that surround us. It means seeing the night sky not as something distant and unreachable, but as something intimate, something you are woven into atom by atom. The infinite is not a destination waiting somewhere ahead. It is the reality we already inhabit, the space that holds us now, the quiet expanse we've always been part of. It is the blanket above us, stretching from horizon to horizon, even when we forget to look up. And so the journey that began with a simple glance toward the stars, the journey that carried us through galaxies, through clusters, through the great architecture of the observable universe, gently circles back to where it began, the human experience of standing beneath the night sky. We are still here, still looking upward, still listening to the silence of space and the slow, ancient light drifting toward us from worlds we will never see. The infinite stretches endlessly beyond us, and yet it holds us close. To rest beneath it is not to come to the end of anything. It is to settle more deeply into the journey, knowing that the cosmos is vast, that we are small, and that those two truths together create a kind of peace no words can fully describe. As these thoughts settle into a quiet place within you, the universe continues above, steady, luminous, unhurried. The galaxies remain where they are. The stars go on shining. The space between them stretches softly onward. You do not need to carry all of it. You only need to remember that you are part of it, that you belong to this vastness, and that it belongs to you in return. If drifting through these reflections brought you comfort, you are always welcome to return. This space will be here whenever you need to breathe a little slower, to think a little wider, to rest a little deeper. If you wish, you can share this moment with someone who might need the same sense of calm. For now, allow your breath to grow gentle. Let your body soften, and let the quiet enormity of the night sky hold you as you drift. The galaxies will still be shining tomorrow, and the universe unchanged, patient, infinite, will be waiting. Good night.